Good afternoon, OpenSlava. How is everybody doing? I'm looking at the Hopin platform right now. So if you are here and if you're at OpenSlava day 2 or half day 2, let me know in the chat that you hear me, that you see me, and that you are super pumped to go for the second day. And it would be cool for the people that are just joining in the first day OpenSlava. Welcome. Yesterday we had a great day. I'm not going to tease it too much because it's gone. It's the past. We have to look at the future. But we had a great day. So if you're just joining, welcome to OpenSlava 2020, the first edition that we're doing live. Of course, we all want to be physically there, but look at what technology is providing. We are doing it. And this is also, yesterday proved it, a great experience. So if you're new, welcome. I hope you're having a great day. I'll tell more about it in a second. For the people that are just joining in from the day before, let me know if this is your first or your second day and who you are looking forward to. So is it your first or second day, and who are you looking forward to seeing here today? I see some people saying thumbs up. We have the clapping emoji for the people that just joined for today. Very important, because it's the only way we can let the speakers know that you're excited and that you really loved it. So the standing ovations at home, you can still do them, but we can't see them. So we have a second day. Robert is there for the second day. I hope you're also there for the third, second. Ooh, a lot of people returning. Nice. This is cool. Second, someone is just there you go. Super excited. Josh. Now, like I always say, this is the 4th year that I'm hosting it. For the people that don't know me, I've been doing this for a couple of years now, and I'm not going to claim that I'm very technical. I have some background, but definitely today you're going to have to help me with the questions, because yesterday was more about vision, future, the trends, and I could come in and interact with the speakers, but I looked at what everybody's going to talk about, and I have no clue what they're going to talk about. But I see a lot of people saying Josh Long, he's the rock star. So probably a lot of people have posters in their room or in their office right now with Josh. Second day, we have a yes. She's just very pumped to be here. So that's great. We have a lot of people returning. So keep Jesse and Josh. Okay, so Dominica, you're going to stay till the very end. Very cool with us. I'm also looking forward to the 2 gentlemen, because they haven't said so much about them, so I don't want to raise too many expectations for them. It's always nice as a speaker to come in a normal level, but I'm very curious to hear them talk. And like I said yesterday, if you're now watching and you have a tech background and you're into coding, you're a developer, you make software, into architects, UX, whatever, you're going to have a great day. Definitely looking at the speakers lineup. If you're more into the business side, the strategy, the future side, and you're saying like, hey, I'm not super tech background, but I have to work with all the technology and I have to make sure that we are future proof, also stick around, because like I said, I've learned so much over the years at OpenSlava. I watched so many speakers do live coding on stage, and now I can talk to my development friends, and they sometimes have to look things up that I say, because I remembered it from OpenSlava. So definitely stick around. Someone is here for the 5th day. Very nice. Try not to drink before OpenSlava. That's always a good thing. But I'm glad that you're all excited and looking forward. Welcome to OpenSlava, and also for the people that are watching through YouTube and are watching on Facebook, welcome. If you want to participate, if you want to ask questions to the speakers, go to the Hopin platform. Just go to openslava.sk. Of course, it's perfectly fine where you're watching right now, but if you want to interact and you want to join in with the competitions we have later today, you want to give feedback and you want to interact with the speakers or me, go to the Hopin platform via openslava.sk. You can join in the conversation and you can tell me who you are looking forward to. Okay, let's see what we have here. So pod speakers. Yesterday we had more than 540 people joining, which is crazy. Definitely, and there's so much offer online for different conferences. So very happy and seeing all these people return here today. Also, we have the expo for the people that were there yesterday. We have the expo at 20 minutes past 4. I don't want to scare you away from this room, but if you're like, I want to do some tech demos, I want to see what's hot in tech for business, what's hot in tech for the good, the NGO, making society better, at 20 past 4, and I'll mention it again, the expo in Hopin. So you can see now we're in the stage era. You can go at the button to the expo and you can join the tech demos there. And of course, if you want to see your favorite speaker, join back here into the stage room. I'm sometimes also going to look to the right. For me, that's my chat. I see your conversations coming in. And if I look weird, it's just that I see myself in delay 30 seconds. So sometimes I scare myself if I'm pointing at the screen and I see something doing what I did in the past. Okay, so we have cool things coming up. Can we see? Yes, we all have the clapping going on. All right. If you want to join in, not only on the hop in, but you want to share, because I can't do a lot of exercises with you. If you want to share what you're doing right now, seeing your setup, how advanced, what computers you have, if you have 5 screens open, let us know, hashtag OpenSlava or at OpenSlava on Instagram, on Facebook. I will repost it, we'll interact with you because we're curious. Yesterday, and this also might be a cool question. Yesterday, we had people from Tunisia, we had people from Singapore, Slovakia, Italy. So also today, if you want to let us know where you're from and where you're watching right now and how you're watching, feel free to share that. Now, I forgot one thing. For the people that have no clue who I am, I've been talking for 5 minutes now. I'm Marnik Vandenbroek, by the way. Pretty important. I'm your host who will guide you through the day. Okay. Now, before we start, before I go to the first speaker, the announcements, let me check if there's still any questions. We got Tunisia's back. Check in the chat. We have Tunisia back. Welcome back. We have Prague. Love that country, Prague. It's a great country. welcome, Carl. Lovely to have you. Love you here. And that's the cool thing about online. You know, it can go so much more global. You don't have to travel, so people from all over the world can follow this. We have Azerbaijan. Very nice. Look at that. This is going all over the place. Just check. Very, very cool. I'm from Belgium, so I'm coming to you live from Belgium. So a bit OpenSlava is all over the world. And what I wanted to say before I announce the first speaker, normally I have the practicalities like, where's the toilet? What's the Wi-Fi password? All that stuff that you have to figure out yourself in this kind of a conference. So I hope you find the toilet, hope you find the Wi-Fi password, or you wouldn't be looking. Stupid question on my side. And the cool thing is also today, not just that we have great speakers that we're going to dive into the tech, architecture, UX, Spring, Kubernetes. I'm just saying words, but you probably understand what I'm saying. We have someone from Germany, Borneo, coming in. Very nice. A lot of speakers, but it's also a day that Accenture was organizing this beautiful event for I think the 8th year already. Also the day that they announced their new purpose, and it's a really cool one because yesterday in the panel discussion we were talking about it, that technology these days it's not just there to be technology, and the things that the audience you are doing right now is just not, we're making cool stuff and we're doing things online and we're making robots and all that stuff, but it's more about how can you impact, and you have such a great impact on the world and society. And we talked about that yesterday, that the human part, the making it change every single day to face the challenges that we have today and also in the future for society, for the climate, for customers, is what this OpenSlava and the whole idea is about, bringing humans together about technology and making a positive change. So this also their promise, deliver on the promise of technology and human ingenuity. So before I announce the next speaker, I just want to say, let there be change.
Change is all around us, shaped by technology and human ingenuity. We can make it work for you and your business.
Okay, and let's see if I timed this right. Either you're now seeing me again and you're like, whoa, this went really smooth, or you're still looking at the video and this is really weird. You see this in delay. So welcome back. And I see in my virtual room, in my backstage, my virtual backstage, I see that the first speaker, she's already waving at me. You can't see it, but she's already waving at me. Nod if you're like pumped to get started. Yep, she's nodding. It's a thumbs up. She's ready for it. So without further ado, let's kick this conference off. Like I said, it's more tech day, but it's going to be a very, very exciting one for you. The next speaker is Stephanie Walter. I hope I pronounced it right. Stephanie Walter. She's a UX designer for Maltem. And in general, she eats, sleeps, breathes UX design. She's a Google Dev expert. Her claim to fame, which I thought was standing out, was helping redesign a monitoring panels for tower cranes once upon a time. And she is, I'm going to mention that later on, she's also going to do a workshop tomorrow on UX design. So if you want to join that, you can via mailing info@openslava.sk, or it will be pinned in the chat if you want to, after this talk, be like, Stephanie, you're my hero. I want to join your workshop. Well, you can, and we're going to put it in the chat. But first, let her do this presentation. She's going to talk about designing adaptive components beyond responsive breakpoints. And I was super happy when I read it because it actually makes sense also for me without the background. Like, what are the breakpoints and responsive design is a question she gets a lot. But it's about, because we're thinking about the concept about screen browser size, but she's more of a fan, like thinking about what context is the use? Why are we in essence making this? So that's what she's going to talk about. So if you are ready, Stephanie Walter, give her a digital applause with the clapping. I already see clapping coming in, Stephanie, so people are pumped. Stephanie Walter, the show and the floor is yours.
Hi. Can you hear me first?
We can hear you perfectly.
Yeah. Okay. So you see my screen? Everything is all right?
Yep.
Cool. Okay. So hi. Thanks for having me. I loved your introduction and everything you said about technology. And this is really, really, really important topics as well. So as you said, I'm Stephanie Walter. I'm here today talk a little bit more about how can we design adaptive components that will be far beyond breakpoints. You can find me on Twitter at Walter Stephanie. I also have a website and the slides, and there's a transcript of this talk already available on my website, because I have some little demos with things that are responsive that you can play around. So after the talk, feel free to check my website for these kind of things. The first thing we talk about is about designing beyond these arbitrary mobile screen sizes. Can you believe this book is already 10 years old? So this is the book kind of about responsive web design. It was written 10 years ago by Ethan McCarty, and he was introducing three things. He was introducing fluid grids, flexible images, and those CSS media queries. So at the beginning of the web, when I started as something we used to call web designers, I think we used to do those super static mockups in Photoshop, and nothing was moving around. It was like as if you were kind of building a picture of a website, and then you had people like developers and front-end developers do the actual code behind that. And then came along the mobile, and all of us were like, okay, how can we make like those super not flexible outdoor website work for such small screens, things like that. And this is basically how we've been kind of building websites for the last 10 years, which is we use those media queries, so those kind of CSS conditions to say if the viewport is smaller or larger or things like that, then this width, then we change the component. So usually the first question I get, and apparently I'm not the only one, is, okay, so what breakpoints do you recommend in my designs, like 320, 768, something like that? And unfortunately, there's no perfect answer. So my main advice would be don't try to define your breakpoints based on those really arbitrary device width or target widths. You need to understand that in order to have like truly responsive components, you need to base those components on the layout and the content, and not on, let's say, an iPhone or an Android specific devices, things like that. So while working a lot with developers, because I'm usually like the designer who spends a lot of time talking directly to my developers, I discovered that you can actually break those components and break the breakpoints in two different categories: primary breakpoints and secondary breakpoints. So what I call primary breakpoints would be breakpoints that adapt to the design based on a layout. This is usually where you'll have your columns, for instance. And the secondary breakpoints, and those are, I think, the most interesting for this talk, are most of the time those small little breakpoints you use to adapt your design at really component granular level. So primary breakpoint usually looks something like this. So I will talk about a cooking recipe website. Let's say I have a category for, I don't know, Halloween food. Let's talk about Halloween food. So we have a category with all the Halloween food, and usually in the sidebar, you have some filters to actually find what you're looking for. It could look something like that. So you might have a breakpoint at 180 pixels to say, okay, on the small version of the website, the filter sidebar is hidden behind the button. And then when the screen gets that large, we have a sidebar that is like, I don't know, 300 pixels, something like that. And the rest of the content is on the right. So those are my primary breakpoints. is usually those breakpoints, those CSS breakpoints, where you are going to trigger your major layout changes from 1 to 2 to 3 columns, whatever you need. And those designers, they will usually, apparently, if you're kind of lucky, provide you with 2 versions of the page. So a desktop, which is a big one, and a small one. And you're like, okay, well, I have 2 components. I can make that work as a developer. So you say, let's use the small component on the mobile or smaller viewports. Let's use the big components on the big layouts. And ta-da, all right, we're done. But the problem is, in real life, there's things in the in-betweens, especially today where we have all of those different screen sizes and mobile sizes. Also, you have iPads where you can actually dock the content on the left, on the right. So you have like this multitasking. So you have no idea what kind of screen size your users are going to be on. And the problem is, if we only have those 2 components, what do we do with the in-betweens? So usually the developer will try to do something with the design. It will be maybe, okay, we will stretch the image, but you see that it's kind of already looking a little bit ugly. If you're not like lucky with the image, you'll have a really strange cropping and maybe you will not even see the actual food you wanted to show. Here it's like floating around on the left. It's not really easy to read or anything. So this is where I introduced the concept of secondary breakpoints. So those secondary breakpoints, usually we are going to work on those with the developers directly at component level. And this is the kind of thing where you want to decide in the browser. It's basically you put a breakpoint when the content breaks, when it doesn't look good enough, and then you try to change the layout. So now with 3 breakpoints, I have something like that, like small, medium, and large. So my small is still used on like smaller screens, smaller viewports, and then I have these in between. So my secondary breakpoints are actually in purple. I could say, okay, if the device is a little bit wider, or if the viewport is a little bit wider, like 650 pixels, maybe we switch to the medium size of the component to avoid the kind of really strange stretching in betweens I showed you before. Then maybe the large component, we could use it even before switching the layout. Maybe we could already have it if the screen is particularly wide, like 820 pixels, but we still don't have the sidebar. Here we could already say, okay, here, let's switch to this large component. So something like that. And then in the end, if I look at my desktop website, I have actually 2 media queries that were triggered here. I have the one to switch from the medium to the large component that was triggered a little bit before, so in 820 pixels. And I have my primary breakpoint, so the one in yellow here on the left, which is basically the one that is triggering the layer change. So the sidebar that was hidden on mobile is now displayed. So this is a mix between my breakpoint at component level, which are my secondary one, and my primary ones, which are really at layout level, global layout. So how do you build such components? So this is basically something we will go super deep tomorrow in the workshop. So if you want to come, again, there's apparently new places available. So feel free to contact the organizers. But yeah, first, what we need to do is basically understand your content. So we are going to build a content model and we are going to try to prioritize this content. If I look at my recipe, let's call it teaser or overview, this is composed of a few things. I need an image because we're building a cooking recipe website and no one is going to try recipes if they don't show, if you don't show them what it looks like. It has a title, it has some categories. We have some ratings. We have the ratings as a number of votes. We have kind of an excerpt summary to tell a little bit more about the recipe, but without going into full details. We have a save button here with which is on itself, you could say it's a component because it has an icon and a label. And we have some metadata, which again could be abstracted into a component if you want, like preparation time, cooking, serving costs. And we have hidden actions here. So you can do 2 actions basically on this one. You can click on it to open it. Then you have the full screen detail of the recipe. And you can actually save it because I've decided my website will have some favorites, cooking recipe lists. So now that we have that, the question is, okay, what kind of content is should be shown as a priority to the users versus what kind of content could we actually not show directly, or maybe hide, or show into the full screen version, or show a little bit further down the journey. So the interesting part about actually building this content model, it's going to help a lot of people. It helps designers create the components. Like me, now I have like basically all of the ingredients for my wireframes, and I can start designing it. Also, it helps us make sure that the vocabulary on the website is consistent. Save means we are going to save, to use the word save everywhere. And then we can kind of avoid having those add to favorite, or maybe in 2 weeks or in 3 weeks, another designer is going to create another component with the same saving feature. We want to make sure that all of those have the same vocabulary. And then it also usually helps my developers understand the model. So it helps them kind of prepare the content. They know that they might have to fetch different API, different backend endpoints in my system to be able to bring those pieces of content together. So I'll do a little exercise, which is called setting priority content. And it's basically, I consider content as something you could put into luggage when you are traveling. And I'm sorry, this used to work a little bit better when we were allowed to travel. But keep on with me, like humor me. So usually when you travel like long distance, you are having like 3 kinds of luggage. You have hand luggage, which is the luggage that are going under your seat. Usually in your hand luggage, you put your most essential content. You put your mobile phone, you put your boarding pass, you are going to put all of the things you need during the travel, like your wallet, paper, stuff like that. Then you have cabin luggage. So cabin luggage is the luggage that you have on top of you during the flight. You are allowed to use that while once the plane took off, but you can't access this kind of stuff while it's taking off or while it's landing. So this would be kind of my second priority. Here you would put the things that you want to use maybe during the flight trip, but also the things you really need as soon as possible when you arrive. So usually when you look at travel blogs, they tell you, okay, put a few socks and fresh underwear in those in case they lose your hold luggage. And then the hold luggage is the last thing, is basically the whole luggage you are going to give it to the check-in. And yeah, sometimes maybe the people at the airport will lose their luggage for a few days or something like that. So in the whole luggage is really everything you will need once you will arrive at destination, but you don't need this during the trip. So it's a little bit the same for the content. What you want to put in things like navigations or teasers and items like that is the kind of content the user needs during the trip, during the journey. And the journey here being, I'm currently navigating to find a cooking recipe. And then in the whole luggage, it will most of the time be the full content of the page, which is the end of the trip, which is, okay, I found the recipe, I'm going to read it, and then I'm going to cook the dish. So how do you decide? Well, you need to do your user research. You need to do your homework. You need to interview users. You need to understand really their needs and things like that. Also, it might depend on your website. If you're doing a cooking recipe website and your unique selling point is to say, okay, we are providing recipes for people who don't have time. And then maybe one of the most important piece of the content will be, how long does it take? If on another hand, you are, I don't know, cooking a cooking recipe, building a cooking recipe where you say, okay, it goes around ingredients and we want to provide alternative ingredients, things like that, then maybe the cooking time is not a super important feature or content anymore, but the recipe ingredients are becoming a more important feature. So here in my case, it was pretty generic. So what we decided is, everything that goes under my seat is, of course, the image is super big, it's wide. You want people to look at this really beautiful pizza and you want them to cook the same one. Then the title, because they need to know what to cook. And also the ratings are quite important, because this is something that we refer as social bias. So the idea of social bias is that people, when they see rating online, they tend to trust it. And if you have something that has good ratings, most of the time people will click on those kind of items more, because they imagine that first, like, the ratings are genuine, so other people actually are kind of promoting this kind of content. So it creates this kind of bias and saying, okay, if other people like that, maybe it's a good recipe, things like that. And then the stuff I can put to the hold, and this is the reason why the small component doesn't have all of that, is all of the metadata I have here, like preparation time and stuff like that, because those I will find them back on the recipe details. So again, do your research, think wisely before not showing some kind of content for specific screen sizes, because if you take decision without doing user research, most of the time you might end up taking the wrong decision, or maybe you will not take any decision at all because everyone in the room will have their own opinion, and then it will become an opinion debate instead of actual design based on user data. So I've designed these 3 components. I say, okay, the small version is on smaller screen sizes, medium and large. The question I ask now is, but could we actually imagine reusing these components, not only for responsive web design, but maybe for other things like reusing these components in other contexts and things like that? So this is where I'm trying to kind of design toward this kind of automagical idea of condition layouts. So we have the concept of modular design. So we used to design those really pretty pages, and it was kind of a picture of what we wanted as a website. Today, designers are more into like reusable modular components. Instead of designing those really fixed width pages, we are really trying to design this set of components that work with each other that you can reuse from pages to pages. And then we call those things usually design system, which is the place where you show all of those little boxes. So I on purpose use a Lego illustration here, because this is kind of basically most of my work is like building those little bricks of Lego that will work together, that we can reuse across the whole website, but also across different screen sizes to make it work. So could you reuse this elsewhere? Could we say, okay, this is the small version of my pizza, my cooking recipe teaser. Can we imagine actually having this on other pages and maybe not only on the mobile version? And I'm going to drink while you think about that. So you could imagine that at some point, since we have, I don't know, Halloween, we could have theme pages. You say, okay, in the beginning of the year, you have all of those recipes around like winter dishes, stuff like that. In the summer, it's salads and things. And around Halloween or autumn, you have all of the pumpkins recipes and things like that. So here, it's not really a category. It would be a page that is going to feature a really specific recipe. And you could say, okay, if I want this page to have this kind of card layout because it's super trendy and it works quite well when you have like beautiful visual, you could say, actually, my mobile component, like the small version of the component, we could use this in a masonry grid, and we could use this card, repeat it, and then we don't need to redesign the component. We already have everything we need to build this page. You could say, okay, then on top of my cooking recipe, I have a blog, and maybe I want to promote some of those recipes. So here again, if your card is quite small and it fits in a smaller viewport, like 300 pixels, something like that, it could fit in a sidebar. So again, you could reuse this component in someplace else, like a sidebar. And if you take a look at usually the full detail page of a cooking recipe, at the bottom of the page, what you try to do is to keep your users on your website. So if they didn't like the recipe, you want to provide them with extra content. So we call this internal link building, things like that. So you could say, okay, maybe we could, again, reuse this component, but this time it's going to be a slider of a few cards with recipe on the same theme. So like Halloween, pumpkins, things like that. And I really like this example. It's from Sarenza, and they were quite smart when they built their sidebars. So if you take a look at the code of the website, you'll see that basically the mobile version of the sidebar is exactly the same as the code they're using here for the sidebar. So the only difference between those two is here they fixed the sidebar to 300 pixels, or no, 25% of the screen, and they used floats. Yeah, floats. No Flexbox, but still they used floats to have the content on the right. And the mobile version, they just like removed the width and it's positioned fixed behind the button. And that's it. So they really pushed this to say, okay, the sidebar, we don't need to reinvent the wheel. You know what? The mobile sidebar, we just like hide it behind a button. We remove the width, and it will stretch on the whole mobile browser, and that's it. And that's super smart because then you only have one component, and it's really easy to adapt and everything. So again, how do you build this kind of robust components? Content modeling. So I talked to you a little bit about that before. I'm going to take a kind of easier example on smaller ones. So for one of my clients, we are currently designing something we call entity link items. So the entity link item is basically a link to something in our content, and I'm using something on purpose. So the first something I had to design was a link to the operations. So it's kind of banking stuff. So I said, okay, what's the content of model of my operation in this case? So here for this small little links, I want the name of the operation. I want an ID number, and we decided that operation and different types of entity, they also have this little icon so that the user can quickly see them and differentiate each item type. And then it has a link. So I have my basic kind of operation link item. And then I asked myself, okay, but I have operation, but I have other things in my systems. Are there variations or other type of content where I could use the same component? And in my system, I have kind of three things where I can reuse that. I have operations, contracts, and counterparts. And all of those three different things are completely different. Like in the end, when you arrive on the full detail page, it's really another content. But at the core, I was able to extract this kind of same content model for the link, which is a name, an ID number. So the ID of the operation, the contract, and the counterpart is not the same form. It's not the same kind of, here you have like an hyphen, here you only have a few numbers, things like that. But in the end, it's an idea. So, and then I have the different icons. So here now I have like one component I started designing, my operation, but I can also reuse this component for the variations of the component. And then the question is, where can we reuse that? So at the beginning, I was designing it for a tile that we have on the homepage. So the user can bookmark a lot of things in our interface. And then we said, okay, we can need my bookmark style where they can have a mix of everything they bookmarked. But then I started thinking about other places where we might have this entity link, which is basically a link to the full detail page. And we have also that in a kind of other form, but we were able to kind of put the components together in the search bar. In the search bar, we have this kind of a little bit complex search that we built, but it's basically as soon as the user entered 3 characters, we are trying to bring to them directly the 5 top results that match the 3-character results. So it means that if they're lucky, and most of our users, what they work with is the IDs of the name, so they actually know what they're looking for. So if they're lucky, they will get really quickly to what they need just because you have this kind of quick search. If not, they hit the search and then they can filter. They have the full, really advanced detailed search. But at least here they have already the component. And I say, okay, we could reuse the exact same thing. And then I checked in the interface, and of course we have the search bar at the top of most of the pages. So then I also needed this for the top bar, but here it's a little bit more smaller. The container is 360 pixels. So in the end, I had one component, which is my operation entity link. And I was able to use it for 3 variations, operation, contract, and counterparts. And then by looking at my interface, I was able to also say, okay, we can also use this for the search. And then we have the big search and the small search. But in the end, it's all the same components. It's just going to adapt and be reused. And it's going to be built in a way that is easy to adapt and get reused. So usually when I do this kind of exercise, what I try to do is also to document the component. So this was kind of based on atomic design, atom molecules component, things like that. So we had a list of all of the components in the wireframes, and we basically linked in the documentation this to every, I'm sorry, it's in French, but to every single page where we were using this component. And this was really helping the developers also kind of build the interface and make sure that we're not building extra components for nothing, and we are really trying to reuse all of that. So from ideal condition in design tools, how do you bring that kind of stuff in the browser? Jen Simon, she's an amazing lady. You should totally follow her. And she does a lot of things around grid on YouTube. She has a channel dedicated to that. She gave a really interesting talk in 2018 at an event apart, which is called Everything You Know About Web Design Has Just Changed. And she introduced this idea of intrinsic web design. And this is a little bit of how someone else like Jay Freston paraphrased it, so I'm going to read that to you. So instead of changing styles based on the size of a viewport or how big the screen of the device is, components automatically lay themselves out based on their own ideal condition. So to translate this into my language as a designer, it would be something as, okay, as a designer, my job is to show to my developer those ideal conditions. This is what I did with those like small, medium, and large. But I never told them, okay, the small is for 200 pixel or 228. I'm like, then what we do is we put those components in the browsers and we discuss. We decide directly in the browsers how they will adapt. And today we have quite a few cool things called grid layout and Flexbox. And you can actually, with those two specifications, so it's CSS specification, build components that are able to adapt without needing any media queries. So this is a demo by Adam Argyle, and I hope the video works well. So the code is at the top, and you see it's like flex, wrap, and he's using like all of this flex property. And you have like 4 different layouts with this form. This is a small, medium, this is a little bit larger. And then if I keep on making my viewport a little bit bigger, it stretches. And there's not a single media query here, so I'm showing you the code. I put the demo in the article as well. So the idea here is, thanks to Flexbox, he was able to build a component that is able to adapt. So here I was playing with my browser size to adapt it. But what you have to imagine is here I put that component directly into different container size. And then thanks to this all like flex situation, the component is able to adapt. So if I put his component in a small container, so in a small parent, it looks like that. In a big one, it is able to stretch, and everything in between, it's going to be able to adapt. So that was a demo for a form. The question is, could we do that with my cooking recipe website? And Geoffrey Kraft actually was inspired by my kind of attempts, and he made a demo. So here you see my cooking recipe website. I have the 2 components on the screen, and he has like a small version of a container and a larger one. And here again, it's able to adapt. So he's mostly using Flexbox, and he wrote an article about that on CSS Tricks if you want to check it, if you want to see how he did it. But basically, he was able to build this responsive component for my cooking recipe teaser without a single media query. And the fact that he built this without a single media query, again, it means that if I put this component in a smaller context, in a small parent, like a sidebar, it will look a little bit like that on the left. If I put it on a bigger container, then it will look a little bit like that. So it's a mix between Flexbox, clamps, and other things. So if you're interested into this kind of stuff, there's a lot of people who are currently doing amazing things like that with Flexbox, grid layout, min, max, and clamp. Just Google like responsive web design without media queries, and you see there's a lot of different demos. So what can we achieve without media queries? The kind of drawback is we can't do exactly what I wanted, because in my version, I wanted to show the metadata on the big version, but I didn't want to display them on a smaller version. And I wanted the save button to be on top. Since I don't have media queries to detect the screen size, then I'm kind of a little bit stuck to keeping the same flow, and I can't like hide and show different elements. So we can do something like that, which honestly for me is already quite good and interesting. But if I really wanted to have something like that, we would need something that is called container queries. And container queries is kind of a joke on Twitter. Like I think every week or something, I have someone say, container queries, do developer want them? Yes, please. So the idea of container queries or element queries, it was called like that, is with media queries, you are changing the layout of the component based on the viewport width. With container queries, the idea would be able to change the layout based on the parent or on the container width. So at the moment, this is not technically possible, but there's like people working on that on specifications. So for the moment, you can't do that in CSS, but some smart people like Philip Walton tried to emulate this with JavaScript. So he's basically using something called Resize Observer. And here you have a sidebar card on the right side, and you have a calendar on the left. And you see here the card on the right, but also the calendar on the left. It's adapting, but it's not adapting when I'm like resizing the screen. I took the screenshot on purpose with my browser open with the background. It's really like, it's adapting to the size of the parent. So whether I put this card in a smaller container, in a bigger container, things like that. So this is really the idea to say, okay, as a designer, I'm going to build those components and then I'll be able to use them in different contexts, and not only for responsive web design, but also for sidebars, for smaller container in search results, things like that. So usually when I say that, I have a lot of designers who look super weird at me, but I really think that whatever like the technical part you're using, if you're using grid layout, Flexbox, JavaScript, whatever, as designers, we really need to stop obsessing over pixel perfections and embrace this kind of fluid intrinsic nature of the web, because it's not print design. We are still kind of in this mindset. We are designing something in tool that are not super flexible. We are trying to compensate for that with designing the same thing at different sizes, but still. So my advice would be designing tools, whatever you want, Sketch, Photoshop, Figma, Adobe XD, and then take the decision in the browser. So decide in the browser. That's my main advice to you, which is start designing those components and go to your developer team, have them implemented, discuss with them, like check in the browser, maybe the media query to change this would be 120, 125, like fine tune this kind of things in the browser if you want to have this like really, truly flexible experience. And yeah, stop obsessing over pixel perfection. It's not worth it. So another things when we are designing these components, we usually tend to forget as designers is we design for the happy path, and the happy path is usually, okay, the perfect content, the perfect site, the perfect image, really nice cropping, everything loaded perfectly. And we usually tend to provide those to our developer, which is like the perfect thing. But the problem is, again, in real life, a lot of things might happen to your contents. And as designers, we usually have to provide some answer to those kind of decisions that developer will have to take. So what happens with my content if the title needs 2 lines? Well, it stretches. But then what do I do with the right part? Do I keep it at the top like that? So I have like a little bit of padding and a lot of padding that is going to add at the bottom. If I have 3 lines, then I have even more. Or do I say, okay, let's enter this into the component? So this is the kind of stuff, like if some of the pieces of the content is bigger or smaller, what happens to the rest of the content? This is something I love usually. It's like, okay, you tend to design this component with, again, always the same amount of content, which works perfectly. But then what happens is I have like less or more content to this component. Usually you have 2 kind of solution. You either say, okay, the component will take the half of the content. So it means that then you have like unequal spacing, like vertical spacing here. Or you can say, okay, if we have this grid, it will take the half of the bigger container, something like that, or like mean half or something. And then you have a lot of white space here. And I'm not saying any of those is better than the other. I'm just saying this is the kind of stuff that your developer will ask you when you have like real content in your components. And this is the kind of stuff you need to discuss with them, like what happens when you have different kind of length of content. Then what happens if you don't have value for some contents? Like if you don't have any votes, no, not the value, sorry. What happens if the content is missing? So I don't have an image yet. Do I put a placeholder? Do I remove the image and then it stretches? Again, there's no perfect solution here. It's just the kind of things that you need to think about. And then, yeah, what happens if you don't have the value for some content? So you don't have votes yet. Do you put like 0 votes? But it's a little bit weird then to have the stars, because here, if someone sees that really quickly, they might think, okay, this cooking recipe doesn't have any votes, it's not a good one, or something like that. So do we put something else like no rating available, or do we just remove this part of the component? Again, this is design decision you need to take. So regarding contents, a few tips. Don't use lorem ipsum, don't use fake content. And if you're using fake content because you can't use actual content for different reasons, make sure that at least it has the structure as close as possible to the real content. And to do that, if you are a designer, ask for the limits. So ask your developers, okay, what do we have in the database for that? What's the minimum? What's the maximum? But also ask about average content. Just because you have like 200 characters in the database doesn't mean that all of the content is that wide. Like I have maximum limit in database, which are 250, and the biggest piece of content I have for that is 70 characters, something like that. And if you are a developer and something is missing as the designer, how it should behave, usually we are more than willing to provide those kind of things. We just maybe didn't think about it or something like that. So as designer, also I think we should take special care about designing different interactive states. Like an input field can actually have a lot of different states, like default, over, active, focus. It has a placeholder, it doesn't, it's field, it's not field. We have information, error, all of that stuff. So as soon as you're starting to play with interactive states, you can just like, again, design this perfect field and everything went right and everything. You need to think about all of that. Data population, about things that might go wrong, which is sometimes maybe your contents come from different places. So maybe sometimes you have to wait a little bit for that content to load. So again, this is on the right, the happy path, which is my content is successfully loaded. But at some point, do I need some loaders because the cards take a little bit of time? What happens if I don't have any content for that in the database? Do we display an error? Do we display a message to say, okay, this piece of content just doesn't have anything in the database? Or maybe sometimes you can have content from different areas and you have problems with web services, stuff like that. Then you need to think about data population errors also. Like, is there a way for the user to prevent this error? Most of the time, it's unfortunately try to refresh the page, but sometimes they can do something else. So again, beyond happy path, what's happening while your content is loading? And then like different amount of content. So I designed my bookmarks, but then I had a question by my developer, which was basically, okay, we have 5, but what if the user actually bookmarked 10 things? What happens? Do we stretch the tile on the web page? Or do we put some pagination? Or do we say, okay, we are visually going to display 5, and then we have a scroll bar in this tile and things like that. So again, I'm not saying there's a perfect solution for that, just that this is the kind of stuff that might happen. And you need to be prepared to answer those kind of questions. Like, what happens if I have 100 components like that on the page? What happens if I have only one of those components? Stuff like that. So obviously you don't need to design all of them. I designed them to give you like visual example, but most of the time this is the kind of stuff you can put in a user story. Like just say, okay, if we have like more than that amount of content, we have a button or a loading button, things like that. The idea is decide what will happen and communicate it with the developers at some point. And then how to think behind the happy path. So know where the data come from. Sometimes it helps because then you can say, okay, there might be problems, there might be errors with the loading, stuff like that. Investigate the amount of data that might get displayed, like how many of these items do we have on average for each of the components, stuff like that. and then investigate what might go wrong with this data. And something that helps me a lot, and this is something we will be also doing tomorrow in the workshop, is doing this kind of mapping. So this is basically a task flow for my search. And I'm quoting my developer on that. He said, "Oh my God, this is going to be so useful to me." I'm trying to do my developer's accent, but yeah, basically, so this is a map that is showing how the components is going to work in the different cases. And here I can see pretty quickly that it's actually quite a complex search. And then I can see that we can have no result page. So I need to design those, and then I can have X results, and I have filters. So at some point I also maybe need to design kind of a version of the components where I don't have any results, which is because I have filters. So it's not the exact same thing as not having result at all. It's just if you remove the filters, then you can get your result back, things like that. So this kind of mapping really helps me kind of anticipate the different state of the content. And it also helps my developer actually build those super flexible components with a lot of different interactions. So I talked about components in responsive context, in kind of page context. I want to finish with trying to understand a little bit how to design towards users context. So sometimes you have interfaces that are able to adapt to the different steps in a process. So this is really specific, but if you have a step-by-step process like Amazon tracking a parcel, for instance, or here, this is a kind of mobile application where you can bring your car outside of opening hour to a garage, is basically a really detailed step process. And then you have kind of the same interface and the same components, but depending on the step of your user journey, you will have a page that is a little bit different. So this is a kind of small adaptation that you can do. Like if you are tracking a parcel, for instance, your component will not look the same when it's still at the warehouse versus when it's being shipped to you, something like that. We could also imagine adapting our components to user environment. So this is especially true again on mobile devices, because the mobile devices have a lot of sensors. So you have GPS, you have a sensor for ambient light. So if you take a look at GPSs, for instance, today, one interesting feature they offer is the ability to switch your component from light mode to dark mode. And usually they automatically switch to dark mode when you are entering a tunnel. So it's usually using two things. It's using the GPS to know you're in a tunnel, but it's also using kind of the light sensor of your mobile phone to detect that you are in a dark environment. So we could also imagine kind of adapting, again, our interfaces on our components based on user contexts. And then you could imagine adapting to specific steps across the user journey. If you think about the boarding pass, the user might not need the exact same information when they are 2 days before the trip versus 1 hour before taking the plane. So if you're 2 days before the trip, you usually want to make sure you've got the right airport, especially in cities where you have a lot of airports. But maybe you're not that interested yet in a terminal and gates. Most of the time, you don't even have this information, but you're really interested into the date of your departure and the boarding time. 1 hour before the trip, White might assume that you're in the airport. So maybe the information about the airport can be a little bit smaller, but no, the information that is really important for you is usually the boarding time. And if we can get terminal, gate, and seat, then this is the kind of information. So we could also reprioritize the content based on the different moments in a user journey, things like that. And you could imagine this kind of component being like that on a mobile. And then if you have a smartwatch, you have the same content priorities. So those are super big. And then the QR code is something you will need a little bit later. So you would swipe and then you get your QR code, things like that. So this last part, though, is a little bit experimental because it means that we are basically changing the interface based on different criteria. So there's something in usability called predictability of the interface, which is people tend to get used to the interface, that get used to where the buttons are, where the features are. So be super careful about that if you are going to break this predictability of the interface. test it and do like a lot of usability testing to make sure that it's something that actually user wants and that is going to work with the users. And then again, allow users to manage those features. So this is a screenshot of Google forum where a user is complaining about a feature where the GPS takes decision for them, which is basically it's changing automatically from one to the other. And this person is explaining that they're doing delivery and is making them waste a lot of time. And they would actually to have a button or a way to opt out of this feature to never have this adapted feature again. So if you do that again, make sure you still have a way to give control to the users. So again, you need to deeply understand your user needs to kind of build this kind of interfaces. And something we tend to do as UXers is build something we call the user journey maps. So user journey map is kind of a super long map with all the different phases of a user. So for my like pre-trip, during the trip, at the airport, arrival, things like that, if you think about what do you do during a trip. And most of the time, we usually super interested when we are trying to build adaptive feature into what phases is the user in, what action are they trying to take, and also maybe some touch point, what kind of devices are they using. Another way of doing predict like adaptation to user and to UI, and this is the last one, is basically machine learning and big data. And I'm not a big fan usually of big data and things like that. But at the moment, if you're looking at the results for reproduction rate in Luxembourg, like this was done with Chrome in anonymity mode, but still it has my IP address. So at the moment, if you're looking at reproduction rate, you see all of the results in yellow are epidemiology versus the purple one are demographic results. And since we are completely in this kind of COVID situation where a lot of people are trying to get information about what the hell is this reproduction rate everyone is talking to us about on the news, then what Google is doing is like basically they are trying to adapt the search result based on what other users are looking for. So at the moment you have a lot of results around epidemiology. I'm quite sure that if you took that screenshot like 2 years ago, maybe we would have more demographic results, things like that, or maybe a little bit more balance. So you could imagine like trying to understand your users and learn what other users are doing with machine learning algorithms, things like that. But again, be careful about, there's a lot of issues also with algorithm and big data to really try to adapt these interfaces. So to sum it up, try to think beyond screen sizes, really try to think about what will happen if with the component is in a sidebar, things like that. Try to build reusable components that are able to lay themselves out based on their own ideal condition, which means stop thinking about pixel perfection, stuff like that. Try to design beyond this kind of happy path, happy content, make sure that it will work in a lot of different situations. Conduct user research and do some content modeling, work on your information architecture to take this kind of design decisions. And remember that it's a collaborative process, so you need a lot of people to build this kind of things and especially to collaborate directly with the development team. And if you want to put that all in practice, I built a really nice workshop that we're going to have a lot of fun with a few different exercises tomorrow about content modeling, content priority, and building reusable components. So you can email the team if you want to come to the workshop. That's it.
All right. Thank you very much, Stephanie, Walter. Like I said yesterday, normally this is the standing ovation, the clapping, everybody going crazy.
I can clap.
There you go. There will probably be the digital claps coming in the chat. Thank you so much for the presentation, also from my side, because I understood everything. So that's also like if you can explain it to a 6-year-old, you understand it completely. So I was really happy to see the presentation. The claps are coming in. I don't know if you're in the Hopin platform, if you can see it, but people are excited.
No, I didn't. I forgot to log in.
No problem. That's why I'm here. I can translate it for you. People are saying very interesting, useful, great presentation. I'm just letting you know that they love it. If you want to let Stephanie know, by the way, the audience, they're in the polls. After every speaker, there will be a poll about the presentation. Was it useful? What did you learn? What do you think about the speaker? So if you want to let the OpenSlava team and Stephanie know, fill in the poll. But looking at the clap, Stephanie, you did a great job. There's also, let me check real quick. Let's go in there. There was also a question from Marcel. Marcel, I'm just going to read it to you, and you're probably know more than me. So who should take responsibility for decisions, how to deal with no happy scenarios while designing adaptive components? You want me to repeat it?
That's like, yeah, that's two questions, right?
So
who should take responsibility
who should take responsibility for decisions on how to deal with no happy scenarios, like you mentioned, while designing adaptive components?
So taking responsibility, it's complicated to answer because it really depends how your team is organized. Also, it depends on the responsibility. If the responsibility is like who should decide what goes where and everything, I would say usually it's designers, but you also need to understand that the job as a designer is to understand user needs and to fight for the users, but at some point you also need to understand the business needs. So most of the time as designers, you end up to taking decisions that are kind of a mix between providing what's best for the users while still bringing forward the business needs and business requirements, especially if it's about making money. So most of the time it's a big discussion about marketing. People also sometimes get involved, and developers. So most of the time, this is also why we tend to try to involve as many people as possible at the beginning. This is why we build wireframes and we test them before building the actual component. So taking responsibility, I think like designers should take responsibility for design decision. But at the meantime, they need to be able to take those responsibilities. So they need to have access to designers. They need to be able to do their job properly. And what was the second part of the question? I'm sorry, I forgot.
Yeah, it was two, but I think you pretty much, if I'm looking, answered who could take responsibility for the decision, how to deal with no happy serial design adaptive components. So yeah, I think you answered. I'm gonna ask Marcel, let me know if she answered your question. I think you did, but I'll ask him. From my side, there you go. Marcelo said it's fine. So nice. Good. And then one last one, also from my end, because people are asking where they can find the presentations, but OpenSlava will probably share that. From my side, and you already also mentioned it already, but just out of interest, because also a lot of people in the business, not with your background or the more development background, have to work together. Like you said, a lot of people are involved. And you mentioned the part in the beginning where you were talking about with the pizza and the ratings. You say, well, we see from research that if we do the ratings and the stars, people are more tend to click. I can imagine if you're a designer or developer, where do you get, and you can look at the big data and the algorithms, like you said, but where do you get that info? Do you know, I see so many designers are like, they just make it up, but where can you find that, how users actually interact, what colors, what buttons, what sizes do they actually get triggered from a psychology perspective?
So there's two things. There's like generic user psychology, and you have a lot of book about that. There's like, so this thing's called cognitive biases, which is ways our brain works and ways we think our brain works, and sometimes we get tricked into thinking something. So for instance, if you're on Booking and you see this kind of only 3 left, no one told you need to book that really quickly because you don't have time because other people are looking at it. It's your brain who's doing kind of the math, saying, okay, there's only 3 left. Oh my God, a lot of people are interested. I'm quite convinced it's completely fake on Booking most of the time. I had like only 1 left. I booked it, and then when I went back like 2 hours later, there was still only 1 left. So, yeah, but this is called like cognitive biases. And if you want, I can send you a lot of links. There's information about cognitive biases on my blog, and there's a lot of books around psychology for web designer. I think I've got one somewhere in my apartment, which is like 100 theory, psychological theory web designer need to know. And there's like 100 more. So for generic things about user behavior psychology, there's a lot of information you can find. And then it's mostly about do your own user research, because sometimes you think something might work for some users, but actually you might be in a really specific niche, especially with B2B users, things like that. Like I have a really specific example where most of my users, if I could provide them with an Excel sheet, they would be super happy. So this goes most of the time against any design principles you have, like make the font bigger, stuff like that. Like, no, small fonts, super condensed information, and we're happy. And you're like, okay, we are going to try to find a balance. So this is always like, you have the theory of how does a human brain work, things like that. And you have like the real practical thing, which is how do your user works. And most of the time when you're building like e-commerce websites, stuff like that, of course, it's going to match because it's quite generic. But as soon as you enter some really specific niche, or if you have like internal products or B2B products, things like that, maybe you have to reevaluate some of that part.
Yeah, exactly. And one designer, I don't know if it's true, but one designer once told me that if you want to get men to click on your website and on your call to action, you have to make the button pink. Because apparently men are triggered by pink, but nobody does it. We make it all blue and red. There you go. I don't know if it's true.
Color is tricky because it's cultural. So like black sometimes is death. You have to dress in black for when people die, but then in other country you have to dress in white for such events and stuff like that. Even the checkbox, like we used to put a checkbox to say it's okay, but actually apparently in some Swedish, I don't know if it's Sweden or someone else, like the checkbox signification is completely, it means it's wrong. It doesn't mean it's right. Like the one with that looks like a D. Even that's cultural at some point. So it's really like test on your user to make sure that everything works with specific culture, specific needs, stuff like that. Test it.
That being said, Stephanie, again, I wouldn't normally ask the digital applause, but you gave a great presentation and I see the next speakers ready. So thank you again. Hope you have a great day, evening, morning, wherever you are. People are very excited. So take that home with you and hope to see you soon. Cheers. Bye-bye. All right. Also looking at my backstage, I see that the next speakers are already waving at me and putting the thumbs up. They're super pumped. Now, I see it, chat, people loved it. So I'm really glad that we kicked off this OpenSlava, the second day, very nicely. I hope you learned a lot. And looking outside, because I have my window in front of me looking outside, I'm really happy to be inside because of OpenSlava and also because it's really cloudy outside.
Across any industry, we know the best way to move you to the cloud. Come with us and watch new life come to your business.
All right, welcome back. Like I said, if I timed it right, normally you should be seeing me right now. Unless the video's playing, this is a very awkward moment, but I'm ready. The next speakers are ready. Like I said, they're looking at me. Enjoyed the first presentation. We go from UX to people I got to know, I think 4 years ago from the first OpenSlava that I did. I had a room full of people with red hats on. And I thought it was this gimmick and someone was handing them out and it was just, let's have some fun, until I understood the whole concept. And I see one of the speakers, you can't see it, but I see one of the speakers putting on the red hat right now. And I was like, okay, this is a whole thing. And every year I saw them returning, and I'm super happy that even if it's digital, I see that red hat here returning. And that brings me to the next speakers. And that's, I hope I pronounced it right. I think they're Italian names. Correct me if I'm wrong. It's Natalie Vinto and Fabio Di Vita. Was that okay? They're putting their thumbs up, so I think I passed my my name test. Natalie Vinto and Fabio Di Vita. Fabio, 20 years of experience. Works with solutions around integration projects for enterprise-grade customers related to cloud-based architecture, agile integration, event-driven architecture. For me, just words, but the crowd is probably going wild. You look pretty trained in it. Natalie has a 10 years experience in IT, ICT, software engineer, and he's a developer advocate for OpenShift, helping the community to have success with their Kubernetes and cloud-native strategy. A mouthful. But what they're going to talk about here today for you is the next step in the cloud journey, edge computing with OpenShift. And in general, it's just saying the business is going super fast. Everybody needs to tap, like we talked yesterday, The world is moving fast, technology, software, it's all coming. So you have to keep up and make sure that you choose the right things and the right solutions. And they say edge computing plus all these new technologies that I mentioned before will help businesses and the people watching here today achieve those challenging business goals that we have today. So without further ado, gentlemen, I would say I'm looking forward. The digital floor is yours.
Hello, everyone. Thanks, Martin, for the big presentation. Happy to be here for the fourth year in a row, probably. Started in 2016, so and happy to be here with my fond friend and colleague, Natalia Vinto. We are going to speak about edge computing as the next step into the cloud journey. And we will see what does it mean for Red Hat. Please, Natalia, you'd like to introduce you? Over to you.
Hey, hello everyone. I'm very happy to stay here at OpenSlava again. Happy to see you again, Marnik. It was a long time. We see very, very cool to stay here at OpenSlava also this year. My name is Natalia Vinto. I'm a software engineer and I'm working Red Hat as developer advocate. Feel free to ping me by email or on Twitter at Natalia Vinto. And I'm going to introduce my colleague, Fabio.
Thanks. Yes, I'm Fabio. I work as a solution architect in Red Hat, looking after GSI's technical relationship. Just to say, always looking for the next big way to write, and edge computing looks like is one of them. If you want to ping me, please feel free to do it at my email, fdvita@redhat.com.
Gentlemen, can I jump in real quick? Yeah.
Yeah, please.
I see you looking. It's not God. It's Marnik. We're asking just to have the live stream correct for the coming hour that you're presenting. Could you put it in full screen if possible?
Yes.
All right, that would be great. Thank you very much. Sorry for disturbing.
Nope. Here it is. So edge computing, the open source way. The advent of cloud computing has a big relationship with the amount of money the money coming from cloud computing has a big relationship with the growth of data. And this is from this picture that I suggest you take a look at. And that means that cloud computing and this growth of data is providing a huge opportunity to the company to create a new value for the end customer and create the insight that they can create from this value can improve the services that the enterprise going or adopting the cloud pattern can create for their customer. That doesn't mean that create value from data or going to the cloud computing environment create necessarily a direct relationship with creating value from the data. This is that's a great challenges. Just create applications that create the value from this data. Because the more are the data you have to manage, probably the biggest is the need to create or to deploy application where are needed. That does mean that you probably in the next future, or let's say now, is probably not enough. Just the cloud pattern deployment as we already know, but probably you need to put the workloads next to the customers just to provide the real-time insight. Things about like autonomous driving. Just probably you need to produce some feedback where the cars are instead of moving back and forward data from the neighbors, let's call it the edge, and the data centers, whatever kind of data center you are, public cloud, private cloud, whatever it is. So edge computing is going to provide this kind of benefits. So bringing any workloads and anywhere. What does it mean for Red Hat, which is the point of view of Red Hat regarding edge computing? It just brings computing, storage, and network services closer to users and data sources. And then that has a great consequences in brings also the workloads where closer to user and data sources. Looking at the way we try to draw the edge tiers or how we see edge tiers, we probably can identify 3 or 4 more main layers. One is the provider enterprise core, where we include the core data centers, the one that we are used to know. Then there are the regional data centers, that there is the works as an intermediation between the last mile and the enterprise core data center. And then there is the end user, the edge next to the end user, the one we are going to focus more in the next minutes. And there's the ones that provides the main benefits, but at the same time the main challenge. Edge computing is already happening, is now, is not, we are looking at the future, but it is something that is already in the market, that's already implemented in industry, like telco, looking at the private networks and the virtual radio access network that enable telco provider to scale better to the requirements coming from digital mobile, for example, access, or manufacturing, looking at the requirements coming from implementing predictive maintenance for plants that can improve the way that the manufacturing company can manage things that are not next to the data centers, but are very far. And the same we can tell for the energy and oil companies, which are going to implement the more and more process control, digital process control, and next to the place where this kind of control is needed. And the manufacturing, energy, and telco are not the only ones market where this transformation is happening, or retail. We think about shoppers or remote office. These are all use cases that where edge computing is bringing now great benefits. Which are these benefits? You think about latency or reducing latency, so that if you were able to bring workload services next to the customer and the user customer, it's far easier to provide them. Obviously, the kind of feedback or be more proactive, reducing the bandwidth, because obviously you don't need to bring back and forward data from edge and data center. And I think one of the best benefit probably is resilience, because if you are able to deploy any kind of edge platform where it is needed, you can probably avoid one single point of failure. So if you have one plant with one edge deployment and that deployment doesn't work, this doesn't mean that you will have an impact on overall services on the other plants where you have your other edge deployment. Creating or having this kind of benefits obviously doesn't come for free. I mean, if you think about managing a very highly distributed architecture, probably you have to deal with a bigger complexity. So you have to think about managing small cluster around geographically distributed. And you have probably managed this kind of a complexity with this same team. So you don't want to an increased number of people that have to manage all this kind of complexity. And you have to manage probably a multi-layer stack, I mean, different technology that must be integrated and must be integrated in a consistent way wherever you are, local data center, central data center, edge. Companies, customers have obviously two choices to leverage this kind of benefit and implement their edge vision, their edge strategy. One is just located in vertical solution, provided that very good for sure vertical integrated providers. But beyond the benefit, I think end user and customer, should be have to figure out how they want to move forward the first implementation. So having instead an open, iterable architecture coming from the adoption of open source solution means that you have probably a better way to improve your vision to the edge future. So a continuous open source innovation coming from the way open source work and innovate. For us, edge computing is just part of a broader solution coming from the cloud adoption. So that's why we say this next step in the cloud journey, where we identify three main streams. One is just adopting an edge-enabled distributed platform. The other one is having an event-driven architecture deployed in your edge environment. That means you can identify your services and having an effective way to use your computing resource, mainly if you have to deploy a small cluster into the edge. And last but not least, having AI and ML application, intelligent, as we call intelligent application, deployed in the edge and deployed in a consistent way in all the different kind of edge tiers that probably company have to deal with. If we start from the Red Hat architecture approach to the edge deployment, Red Hat OpenShift for sure has the capability to provide a consistent way to manage clusters, OpenShift clusters starting from the central data center to going to the neighbors, the edge. So you don't need to reskill your a customer doesn't need to reskill his IT department or operational OT department. And also from managing the workloads or building application, building on OpenShift into the edge or building the application in a data center doesn't mean a lot in terms of skills. And you can manage the workflow of deploying applications of what we call CI/CD in a manner that is not that different from the way people already skilled on this kind of platform is used to do now. Looking at the different way you can leverage OpenShift right now in order to have an architecture, an edge-enabled architecture based on OpenShift, we can see that you can deploy a single edge cluster made by 3 nodes, a remote worker nodes, or having even a single node edge server, till to the small footprint device edge. This should be able to fit the different kind of use cases where you have, for example, low bandwidth or disconnected sites. That's the one of the use cases where probably deploying a single node edge server could fit very well, or having space constrained environment. So you can deploy a central data center cluster or in a regional data center cluster and a remote worker, just to deploy very straightforward application. Then you can have probably the need to have a small footprint with a high availability. And that means you can have deployment of just a single node edge cluster. All these different way to deploy OpenShift from architectural point of view can address different kind of use cases and different kind of vertical. Thinking about single node edge server, we can just address, for example, asset monitoring or healthcare data processing. And that means telco, obviously, with the telco 5G far edge radio access network, or manufacturing. Remote worker nodes, think about connected sensor or fraud management system. And so also fintech is impacted by this kind of edge deployment. Edge cluster with 3 nodes. So Red Hat OpenShift and masters and worker reside on the same node. You have so the capability to deploy edge AI and data pipelining. So you have in your intelligent application next where your proactive action must be provided. And this is a way you can, that's a picture of how you can manage from a central data center with single tool of management, all these different kind of deployment. Or looking at a different point of view from industrial point of view, you can have a manufacturing use case where you have to need with IoT, machine learning, you have to manage to deal with industrial control with different factory plant managed centrally, or a telco use case where you have ultra low latency and precision time synchronization. That is not enough, obviously, because having OpenShift cluster empty doesn't mean anything. You need to manage workloads. So you need to bring application where to the edge. What does it mean in terms of needs that must be addressed? Having CI/CD pipeline consistently managed from data center to the edge, or having a declarative current configuration management in order to replicate wherever you want, or in case of need, to manage business continuity, disaster recovery from the data center to the edge, leveraging GitOps patterns. You have data processing from sensor to analytics, managing in a way that's not that different from the way you usually manage a usual application, traditional application. And so using the CI/CD pipeline that we already know. Creating value from that application and delivering them faster is a value for sure. So whatever kind of application you have to deal with, but is not enough just deliver it faster. You have to deliver safer. Safer means in terms of be sure to deliver the kind of things you are supposed to do. So implement the CI/CD pipeline based on whatever tool you want that is integrated with OpenShift. Things about Tecton, the OpenShift pipeline, Kubernetes native way to manage pipeline, or Jenkins as well, from the central data center where you probably have the development phase to the execution at the edge. The same should be true also for intelligent applications. So creating training the model in the data center and deploy the final intelligent application, promoting to production to the geo-distributed factories or plant, whatever they want, in a consistent way always. We don't want to reinvent the wheel. So that's the reason why OpenShift provide GitOps capabilities to having a consistent vision of your workloads through whatever kind of workloads you have to deal with from the data center to the edge throughout the different steps, dev, test, staging, and prod. Even triggered business logic. What does it mean actually, and how is really implemented on OpenShift? Natale, over to you, and please, can you give us some more insight on what does it mean on OpenShift, event triggered business logic? Please.
My pleasure, Fabio. So if you can drive the slide now, we can continue this way. There are a bunch of animations, so if you get them, can click. Yeah, so why serverless in this edge computing world? So if you recall, we had the OpenSlava, a nice OpenSlava session back in 2018, where we were talking about serverless. And the concept is always the same, but here we are trying to adopt this to this new concept of edge. So why we need serverless over here? If you know, historically we were developing with monoliths, application servers, and extensive architecture and design. And now we have this new approach, which is the serverless approach, right? Which is simplification towards Kubernetes. And moreover, it enables a dynamic scaling. That's an important thing. And if we, so what we get from this, that technology is an utility. And this serverless approach is really helpful because help us abstracting this complexity. Some numbers from the market. So 40% of enterprises adopted serverless technologies. We've expected growth coming in next year, or next 18 months. And 60% of serverless practitioners reported reduction of operational costs. So those are very nice metrics to hear about. Let's see, what is that serverless? So with serverless, usually we have an event. This event can be about HTTP requests, Kafka messages. Typically, this event triggers your application, and your application produces some results. So this is the serverless pattern explained. In the context of OpenShift, Kubernetes, cloud native world, what we have usually is a container of a bunch of containers that responds to some HTTP requests from our browser, from our API call, consult a database, and we have this auto-scaling way of delivering the content. The benefit of this model is that you can scale down to 0 when you don't use this service. So you can save resources, and you can scale it up when there are lots of demands. If you think about edge computing, right? We can have really a huge number of devices, of inputs connected. So having this model working here, it's really a big plus for our strategy. And serverless pattern is not only for HTTP requests, right? It's just reacting to any kind of event. If you think about a queue or a Kafka message, so some data streaming, this is another great fit for serverless. So we have some streaming, some message streaming from some external system, and we create automatically a container that talks to a storage, and we can auto scale it up. When we don't use it, this container goes down. And we can see in this slide, we have some operational benefit from adopting serverless, because usually we tend to over provisioning our hardware resources. So we don't know really what we need unless we measure and unless we do all the metrics. With serverless, we have from day 0 those metrics fitting our workloads, because we can just have the hardware resources responding to the real demand, to the real load. And this is the overview on how is structured OpenShift serverless. So how it's made. So you have, of course, the RHEL CoreOS operating system, which is a basic operating system based on containers. Then you have OpenShift, so the Kubernetes enterprise distribution. We put on top on OpenShift this serverless layer, which is component by three modules. One is the serving, the one implementing the scale to 0 we were talking about before. The other one is eventing, the one that is reacting to event, Kafka messages, or any kind of other streaming And then we have the function. So the capability to run just a piece of code and auto-build it, auto-compile it, auto-deploy it. This is the offer around OpenShift Serverless based on Knative project, which is the Kubernetes native serverless implementation. Around that, you can have also an ecosystem of tooling. So we're talking about Knative. Then we can use Istio for the service mesh. We can use some external tool like CADA integration for Azure Function. We can have our favorite runtime. So we can implement our function in our Python, Node.js, Java, Go, PHP favorite runtime. And the builder, the component in OpenShift Server will build the containers automatically for us. If you see, the developer are in charge of the function layer, microservices layer, and the operation SRE people will be in charge of setting this up in top on OpenShift. The key feature here, as we say, is that we have automatic scaling. This is an event-driven architecture. As Fabio was mentioning, with edge computing, we expect to have a massive, huge, lots of data to manage, to handle, to react to. So this is the best fit computing model to deal with those kind of architecture, and moreover, based on containers technology. Let's talk about typical use cases for serverless. So one of the typical use cases is just web application or API. So I want to expose my service. My service talk with some database, something like this. I can build my service in my favorite programming language like Java, Quarkus, Node.js, Go, and Knative and OpenShift will build for me and run this for me. And when I don't use this service will be scaled up, down. If I want to do my blue-green, my canary strategy, I can serve multiple versions of my service, my function, and this can only the one that I need will be really active. So this is very powerful. Another good use case example is this one. So Fabio will talk in details about AI, ML use case for edge computing, but also for serverless. This is a good use case because we mentioned that when we have to react to lots of data, we have to manage lots of events. Think about an automation around machine learning. In this example here, managing some X-ray data for health system. You have lots of data to manage. You can react and scale according and proportionally to your business need with this paradigm. And the data transformation. So data transformation is really one of the best fit for serverless. If you think here in the edge world, so this can be a device of a sensor sending some data, some event. And you can use also on top of Knative and OpenShift, some tool like Apache Camel, so Fuse from Red Hat integration to transform your data. So you serve the data with serverless and you transform the data with Camel in a agnostic way. So this is another great use case for that. And just to recap everything, in this new world where everything is ubiquitous, the computing model has been diffused and dispersed everywhere. So this serverless use case, this serverless paradigm is really helpful, and moreover in the edge computing world. And Fabio is gonna talk to you a little bit more in detail about all those data with machine learning workloads with edge computing that you can serve and manage with also with serverless framework.
Yeah, thanks, Natalia, for presenting a very effective way the serverless part. I mean, I think is one of the main enabler if you want to use effectively an edge computing deployment and fill that edge deployment with effective and useful and valuable application that should consume or use the resources, the scarce resources that usually you have to the edge in a wise way. AI/ML, so create the deployment into the edge or capability to deploy or to consume data coming from the edge and provide proactive action to the inside coming from the gathered data is the third main capabilities that we see as a common requirement patterns across different industry, telco, manufacturing, retail, healthcare, fintech. What does it mean leveraging or harnessing AI ML on OpenShift and mainly with this kind of edge deployment? If we look at the challenges that must be managed usually by the different key personas involved in AI ML application creation deployment, the development of the machine learning model and the deployment of that machine learning model as an app in production are probably the steps that requires more attention in terms of IT management, in terms of how I want to consistently develop and deploy that application, that model in production, whatever kind of we can say kind of cluster, OpenShift cluster we want to run on. So starting from the data center to the edge, and we want to do it in faster, and we want to do it in a consistent way. Red Hat is investing more and more in order to enable AI ML or in order to have implementation of AML workflow in the edge deployment we just mentioned before. That means that we want to provide with our stack capabilities that allows to support all the IML workflow. Usually starting from setting the goal in order to decide the key metrics I want to measure the success of my model with throughout the machine learning implementation and deployment into production. The first question could be why containers and Kubernetes for AML? I would say because first of all, portability. So if we speak about edge computing, I want to be able to freely move the workloads, intelligent workloads throughout and develop throughout all the different kind of clusters I do have in a consistently way without reinventing the wheel if I have to deploy that machine learning model in a standard data center or into the small cluster into the edge. And one second point I would like to underline is I would like to provide a way to provision fast an AML environment. So if I do have data engineer, data science that just want a Jupyter notebook environment in less than 30 minutes, yes, I want to be able to provide it instead of every time deploy a new cluster or a new platform as a service, deploy some tools, recreating the wheel every time. And I want to do it in a repeatable way. So I want to be sure that I do have the same libraries, the same frameworks for different kind of use cases. So the second question will be why Red Hat? Because I would like to say not only because we are very well known for our Kubernetes release OpenShift, but because we already know how to do CI/CD deployments and in a consistent way with the traditional application, and we are going to provide that capabilities also for intelligent application based on AI ML frameworks. And because we were able to establish a strategic partnership with key players in the ML market, like NVIDIA, for example, for in order to use and effectively GPUs. If we just look now at the machine learning life cycle, the usual one, in more technical details, and we can see that usually it goes from identify the metrics, codify the problem I want to solve, and identify the metrics I want to use to measure the success of my model. Then we move to the data collection and cleaning, and in order to implement my feature engineering. So I want to know which are the kind of data that I want to use to train my model. Then obviously I want to train my model, tuning it, and then deploying in production, and have the way to measure the success of that model, or how that model is going through the time. And if we think about the how it works with the usual application, so starting from feature request, for example, then develop, test, and production is not that different. So probably the main difference is the semantic of the single step, but that from workflow point of view is not the difference. That means that the reason why OpenShift is able to provide to the data engineering phase, data science, and app development, the same kind of experience. And from not only from developer point of view and ops point of view, the platform is always the same, and it's consistent in all these different use cases. How we are going to do it? How we're going to provide this capability? Thanks to Open Data Hub. Open Data Hub is a reference architecture, is more than a product, is just a framework, and that is able to provide the different layers needed in a typical AIML application development phase. So tools like the TensorFlow, languages like Pattern, could be Spark, and Jupyter notebooks in order to have data scientists, let data scientists experiments on the data, machine learning data services, or like SQL or NoSQL as well, and then a common hybrid cloud platform managed by OpenShift, leveraging compute acceleration like GPU. And that is true throughout the different kind of deployment, from physical to the edge. So any workload, anywhere. This is a picture of Open Data Hub. It's an open source community project that by which OpenShift can automate the deployment of open source AIML tooling. These are just some of the frameworks and tools provided by Open Data Hub on OpenShift. Just to mention some that are probably the best one for the ones that want to develop an intelligent application. So Apache Spark, I know doesn't need to be presented. Argo CD to implement the GitOps workflow for AIML application. Grafana Prometheus in order to implement and visualize the metrics I want to use to measure the success of my model, and Jupyter Notebook in order to provide a multi-user experience on OpenShift. These are some of the also some of the community we are working with. We already mentioned NVIDIA, so you can leverage NVIDIA CPU GPU optimized thanks to OpenShift. And some key workflows, or some key use cases you are able to manage thanks to Open Data, the framework Open Data Hub. It is the data acquisition and preparation. Provide the Jupyter Notebook as a services. So whenever there is a need for a specific new project, so instead of recreate everything from scratch, you just provide Jupyter Notebook as a services. Machine learning model and serving and inferences. So you can provide a model as a service, and then as we mentioned a lot of time in this during this presentation, managing the continuous CI/CD development of machine learning model in production. Just to show them in more detail, there's the data acquisition part and preparation, leveraging, for example, tools like Apache Kafka, called in Red Hat MQ streams, and feed my Aiml platform. Jupyter Notebook as a service, so you can just provide a, let's say, multi-tenant environment for Jupyter. So with one platform, manage a different data science team. And what is created on Jupyter can be then deployed as a service using frames like Flask or Seldom, or you can just provide an image, an OCI container that could be deployment, definitely on OpenShift, or if you don't have enough resources on OpenShift, on a small environment having just a RHEL with a light footprint. Before going to the demo, where we see just a very simple workflow, AIML workflow, these are some of the strategic partnership we do have in the AIML ecosystem, just to show that we are going serious in this domain. So, and we are in the typical open source way. We understand that you can't do it everything alone, and we like to involve in this kind of community project and other partners, other key players. Let's now see briefly how we can leverage Open Data Hub on OpenShift, just having a very easy way to deploy what is built inside a Jupyter notebook and having it provided as a service. And the final model, we trained it inside the Jupyter notebook.
I love live demos.
Thanks, Natalia. Please don't interrupt me, please. So as you can see, Open Data Hub, like everything now, like third-party software, or also Red Hat software running on OpenShift is deployed as an operator. Obviously, for the sake of simplicity, the operator was already deployed in his small OpenShift cluster. You can see part of the components comprised in the Open Data Hub framework, and you can see here that the instance is already up and running. One of the things that we want to do, just provide, as we mentioned, we have, let's say, a data scientist team that asked for a new Jupyter environment. We want to provide it as soon as we can. So we have already here what we mentioned before. You can see the routes. So that means the service we expose through OpenShift is the Jupyter services with a specific rule. Here we are. We start our Jupyter environment. We have the opportunity to start from the cited notebook image. We will use this one because it comprises and includes all the frameworks and libraries needed for the kind of use case we are going to implement. You can have a t-shirt sites deployment based on obviously the kind of resources you can use. You can specify starting GitHub repository, what we are going to do, where everything is already built and implemented. In case, as is not the case, you have access, so you need access to Ceph storage. You can specify, because everything is, or you want to provide any kind of different storage, you can just provide the key to access, and if needed by the notebook, you can provide the the environment variable. Here you can see the servers is starting up, and everything is available from the data for the data scientist team. Let's start from the feature engineering part. Also, what we are going to do, the first notebook. So we will show a feature engineering technique. So the goal is to turn text documents into vector. We want to be the model we are going to train will be used to see if there is spam documents in a text. We want to be able to split spam document from legitimate text, and we want to be able to do it in an effective way. The way we will start, we will do feature engineering is using a very simple technique. So the text frequency inverse text frequency. So we want to be able to understand if there is a separation. So we will take the training data. We want to see if there is a separation between the legitimate documents and the spam one. So let's run it. The notebook. We are going to use scikit-learn framework. We loaded we created the pipeline to which we will apply our TF-IDF transformer, and that is the plot that show us that there is more or less a clear separation between legitimate spam words that you can see in the bottom and the legitimate words that you can see in the upper part of the diagram. So as soon as we are able to identify the data we want to use to train the model, we are going to do it. So let's load the Jupyter notebook where we have our training phase. We are just going to use a very simple model. So logistic regression, we take a text and we tag the text as a spam or as a legitimate. Let's run it. And also in this case, we are going to use a very simple library coming from Scikit. And in order to see if the trained model is more or less effective or not, we are going to plot a confusion matrix. In a confusion matrix, we have the opportunity to say how many times we identify legitimate words as legitimate, is this box, or spam words as a spam, that's this one. In the other diagonal, you can see actually when you identify spam words as a legitimate, so when the model fails, let's say, or legitimate words as a spam. And it looks like, looking at the numbers, the model is obviously working pretty well. Also, if we look at the raw numbers, raw count, we can see, yes, probably this model can be a good candidate to be deployed in production. Now the real challenge is how I'm sure to have what the data scientists have identified as a good model consistently deployed into production. That's where again Open Data Hub comes to help, because we can build a workflow pipeline, a deployment pipeline, where we will start from the two notebook that we already deployed and created, and starting from this one, what we will have will be just an HTTP services that we can use just to provide the model as a services. So let's start building this. I already built the workflow, and we already have deployed the model as a services. And we are going to see, first of all, how we are going to call it in a Jupyter notebook, and using now a different a different text coming from Pride and Prejudice, and so there are part of the Pride and Prejudice text, and part of that is spam. And one of the biggest thing of this the part where we are going to predict which are the legitimate part of the text, which are the spam. The biggest part of the sorry, I clicked on this one. That's the part. So that's part where we are going to use the services and the model provided the services. So let's run it.
Sorry, guys. I'm jumping in real quick. I know you don't like to be interrupted, like you just said.
No worry.
But can you like wrap it up in 1-2 minutes max?
Yeah, and just to say that we are able to provide also out of the box metrics that you can see here. That matrix shows us, in this case, how many times we do prediction on spam legitimate, how is going along the time, the model. And if you see something like this shift, that means a long time, probably we are going to predict more legitimate words than before. That means probably there is something in this model that should be corrected to some extent. But anyway, this is something that we can provide to the data scientists to say, well, probably this is something that doesn't work. Please, can you take a look at it? Everything, just to close, standard CI/CD to deploy a different kind of application, probably usually one runs on OpenShift, from development, from the data scientist to production, from the data center to the edge, consistent way. That's it. And thank you, obviously.
All right, thank you very much. Like I said, you're probably used to, like with the other speakers, that you're at OpenSlava and then applause and people go crazy. But here in digital, they say it. But I'm excited. I'm excited, and I'm not gonna do questions because the next speaker is already ready.
Okay.
People can reach out to you. Probably already.
Yeah, please.
Know you for a long time. So Natalia Vinto and Fabio Di Vita. Reach out to them if you have questions. I see the clapping hands coming in. I don't know if you're on the Hop-In platform. Thank you so much for doing this, guys. Glad to see you again.
And see to you soon next year in Bratislava.
Let's hope it's physical again. Let's hope. So thank you, guys. Thank you very much. As we will continue to the next speaker in my backstage, she is already looking at me. So she looks pumped. She's ready. She's smiling. She's there. You go. Thumbs up. Waiting to begin. Of course, you can't see it, but she's going. In the meantime, glad that people are coming in with the clapping hands. Hope you enjoyed it. Sorry we can't do the question, but we're going to try to respect the timing a bit. Definitely because we're going to go to 8 in the evening. If you're still sitting in front of a lot of screens, share it with us, #OpenSlava, or on the Instagram, Facebook @OpenSlava. We would like to know, how are you following somewhere in the world this conference? Also, you saw it in the chat, and of course, it's been running for a while now. It's the Expo. The Expo is still live. Of course, I don't want to scare you away, and I want you to stay in the stage room, but I know some people might want to do the tech demos in the Expo, so definitely check that out in the tab. If you have questions, you can still put it up in the chat, okay? And the cool thing is, we talked about a lot of stuff, and yesterday, I think it was Jack who also mentioned that there's also this link between human and technology, and there's also this trust factor. So the next topic that we are going to dive into now is security.
Wherever your business goes, whatever it touches, whoever it works with, you need cybersecurity that covers it all. See how we can give you peace of mind.
Okay. Normally the video is done. There you go. I saw you were asking switch over. No problem at all. We have this beautiful video, and then people are like, oh, nice, very nice. And then we know that we're at the security part. But I see that you're ready to go. For the people that check the program, I'll introduce you. The crowd goes crazy. We'll do a standing ovation, and then you can take it away. So our next speaker is Managing Director at Accenture Labs. Her name is Teresa. I'm trying to pronounce it right. Correct me if I'm wrong. Teresa Tang.
That's correct.
Okay, cool. Teresa Tong, Managing Director, Accenture Labs. You have a PhD in electrical engineering plus computing science at the University of California. Sometimes people say, Martin, that's not important. You don't have to tell that. If you know what you have to do for a PhD, that is something I need to mention. It's crazy. You're responsible for like finding the best breed of next-gen architecture solutions, and you evaluate their impact on the business by experimental prototypes and pilots. And today you're going to talk about how to maximize collaboration through secure data sharing. And as I read it, I think it's really interesting also from my non-tech background to see also, because we talked about it yesterday, in everybody's sharing data. Not everybody wants to share. There's a lot of security, a lot of businesses having their own agenda, but you're going to talk about how we can still look at that data, have it secure, learn from it, and still do our thing. That's my wrap up. I see you looking. That's not what I'm going to talk about. Yeah. Okay, ladies and gentlemen, I hope you're ready. If you have questions, ask them in the chat throughout. We'll do it afterwards. But for now, I say, Teresa Tong, the stage is yours. Have fun.
Thank you so much. And I'm hoping we can see each other next time. But hopefully you can see my screen as well. So I'm about to share. So as Marnik mentioned, right? So we know right now more than any other time how important it is to share data, right? Data is going to drive a lot of the decisions that are being made right now, and so we definitely have incentivized to do that. But trust, as we mentioned, do I actually trust the entities? We see a lot of social media companies, we see our governments, we see our insurance providers, even our employers. Do we really want to trust them with our data? Once you give it to them, they have it forever, and you want to make sure that they're using it for the right purpose. So that way that you really protect the trust of your data, that's going to be a way in which we compete. And we know some digital natives, they don't do such a good job in that, and we actually see that, like they're using our data for things that we might not have expected. Versus an example from Apple a couple years ago. Apple's really differentiated on how they trust, right? So the data within the iPhone, there was a local sort of attack, a terrorist attack in the US a couple years where a husband and wife team actually shot up some of their coworkers. And, you know, the US government asked Apple, could you break the security within your phone so that we can actually see the data so we can fight this crime? And Apple chose at the time not to do this, because if they broke it for this one case, they're breaking it for many other things. And so they really had to stand up for trust and that protection. And it's really differentiated how I think about Apple and that particular capability. So this talk is about a new sets of technologies, a new sets of technology that really protect trust in a programmatic way. So it's not just about legal arrangements. It's not about ethics, but technology that allows us to really track and protect our data and how it's being used. So let's talk about that. I want to motivate with a case study. So this company called, so any large pharma, right? One of the most important things that they do is releasing drugs, and it's a very expensive, very time-consuming process. The whole process takes 10 years. The clinical trial by itself takes about 7 years. And so when each of the trial is set, ideally, we could possibly reuse, some of that data for thinking about other things, right? How effective is this treatment? And the original study might have been looking at treatment in a general population, but I might want to reuse that data to say, how does it actually impact women or Asian women like myself, right? So could I do that and thus make, the drugs better for everybody as a whole? And so this is good for everybody to do this. But then again, it's that issue of trust, right? Do I want to make sure my data, as I'm sharing it with others, are they using it for the right purpose? It should be the clinical trials. It should be for the experiments that you've agreed upon with the other company. And so could I use, someone else's data to train my machine learning models or to find an insight off that data and to use it in a way that benefits everybody? And so this consortium called Melody, right? You can see it's a joint consortium with some of the largest pharma companies, Novartis, Merck, with a lot of the strongest technology partners like NVIDIA, and then some of these startups coming up, right? So it's bringing that together. And this particular case is actually the technology that I'll be going through later in the talk. So the technology is like cooking a meal without being able to see the ingredients. So we all know that data is encrypted at rest when it's stored. It's encryption at motion when you're transmitting it. But what happens when you compute? In the compute cycle, someone has to decrypt it, and then that's where you're running your algorithms that are either going to look at it in sight or do some sort of ML on it. So what if you could cook the meal, do that particular computation step without seeing the data? The data stays encrypted, or the data stays on premise in Teresa's control. So I don't actually have to worry about people using it for things I didn't. And that's exactly the set of technologies that I'm talking about and why it's so exciting. So let me give you 2 more motivation steps before I go in, right? So we know, again, the ability to access data is a competitive advantage. So this Harvard Business Review study found that 78% of companies, they're showing that the ability to easily access and combine data from external sources, it's very important for data-driven decisions. But only 23% said they currently are effective in this area. And only 15% were sharing data with their key vendors and suppliers. You can imagine with supply chains, right, as the world has changed. With supply chains, if we actually had them sharing data, we would have been able to react faster in a way that benefited society. But there's not these mechanisms in place. And part of it is due to trust, right? So when we talk about trust, it remains elusive, even with companies that trust each other. We're partners, we're suppliers, we're vendors. The lack of control over the usage of the data by the other organizations, it's just as important as a risk for companies. 42% that say that's a key issue why they can't trust each other. It's just as important as legal uncertainty over the data, which actually in this survey of the EU companies found that 54% said the legal issue was the only thing that was keeping them from sharing. And so these are barriers to overcome. And the risk of sharing data is sometimes higher than the potential value. This is how people perceive it, right? So Accenture research, we found that having a public data breach as a company, that the companies will see a 10% decline in their revenue for 6 months after the breach. And it could actually propagate over 2 years, right? So that risk and that fear is part of why they're not doing that. So once you give this to somebody else and that breach happens, that's also your data that's being shown. And many of us have felt this in a very personal way, right? As we actually have our personal data, sometimes when we give it to a company and then there's a breach, that feeling that you have, it's sometimes irreparable. So this capability that I'm mentioning again, it's called multi-party compute, is a class. The actual technology behind it is privacy preserving technology. And then we're going to go through that. That's the technology that we think will become something that helps these companies overcome these barriers that I just mentioned. So let me start with privacy preserving technology. This is what I've been teeing up the talk with. So let's start with the millionaires problem. So let's say Bob, Carl, and Alice, they're all millionaires. They want to figure out who's richer, right? But they don't want to tell each of the others exactly how much money they have. So one way to do it is you could trust an intermediary, and you could say, we're all going to tell this intermediary how much money I have. And the intermediary will tell them, yes, Bob is richer. And this is how things work today. If we think about how a lot of companies are sharing data, there might be a common data lake. They might trust a common entity like an Accenture to be that intermediary. And then they figure out a common insight. So it's via certain legal approvals. It's via certain metadata management, looking at data lineage and data access, implementing your RBAC right. So that's how we do it today. But with privacy preserving technologies, there's a way to do this on encrypted data. So Bob, Carl, and Alice can all encrypt their data while it's in their control with the values that they have. And you still might have an intermediary who gathers the encrypted data or to make a sort of computation, but it's on the encrypted data and we get the result as to, again, who's richer, Bob, Carl, and Alice. And you would just say, Bob is richer. And nobody in that chain, including that intermediary, would need to actually see the original values that Bob, Carl, and Alice had. So this is a simple lookup and a simple compare. And there's certainly a lot of value to that already. But imagine this capability done to, a bit more advanced things and advanced problems. So let's talk about some examples of this. And this is really to allow data cooperatives. So if you have trust, this is actually what allows us to then have companies come together and work. So let me start with an example about financial services, something called traders and trading for dark pools. So dark pools is for very wealthy individuals. So let's say somebody at Accenture, let's say Julie wants to move a large amount of stock. And, one is she's monitored, so maybe not a good example, but she has so much stock, I imagine, that any action she make could actually move the market, right, when she sells something. And so dark pools is a way that allows this to be done. The bank, like a Credit Suisse or HSBC, will act as an intermediary. They'll take, Julie wants to sell the stock. This is what Julie wants for it. And they'll look across people who are willing to buy and make that connection. The bank does this. So the bank knows Julie wants to sell. They know how much stock she has. They need to know which price she's willing to offer. And the bank would need to know all the people who would actually want to buy this and which prices they're willing to accept. So you have to really trust that banking entity to do the right thing in that story. Well, with the privacy preserving computation and these data cooperatives, imagine a story where everybody encrypts. So even who Julie is, right? She would encrypt who she is. She would encrypt how much stock she wants to sell. She would encrypt the prices she really is willing to sell it for. And all of us who might want to buy it would do the same. We would encrypt this information, how much we're willing to buy, how much we want to pay for it. And then now the cooperative, the role of financial institution is to actually just make those matches. And only when the match is made is this, shown, the fact that, let's say, Teresa wants to buy a certain amount for a certain price. So we never see the willingness of the whole range of data as far as what she was willing to pay, both the low or the high. And that might be more comfortable, right, in that situation. Let me skip to the last example because I'm going to show how this could work. So let's talk about telematics, right? So telematics and brakes. So let's imagine a supply chain where you have brakes manufacturers, you might have a telematics provider, and then we want to look at things like forecasting, when we need new brakes while preserving the privacy of the user. So maybe as Teresa drives, I don't necessarily want any of these people to know that I might speed sometimes, that I might take corners a little erratically. But for the improvement of brakes, it's really important to know people actually drive the way that Teresa drives, right? And so in that story, what if we could encrypt all this data? So each driver could encrypt exactly their data, and only that encrypted data is shared. The algorithm provider from the telematics manufacturer, that's encrypted too, because maybe it has their IP, their intellectual property with how they want to compute something. And only what's done for the manufacturer is just a forecast algorithm that takes the encrypted data from all of us, the encrypted algorithm from the telematics provider, and just projects forward that says, you order new brakes in this region, right? So we've actually built out something like this. And it looks as follows, right? So each car, each driver, we have something here. This is our data that has things around our brake and the engine, and it might have a location. In this case, it's France. Where am I in France? And maybe a different driver has a different sort of a view. And then the telematics company, all they have is the encrypted data, right? So they're seeing the encrypted values. They don't see the raw values to know maybe how aggressively I might drive or not. And then they might have external data like temperature, but the algorithm itself is also encrypted. And then what's shown to the brakes manufacturer is just a prediction that says, where do you need to order new brakes? And this has a lot of value, right? Because it's allowing the supply chain to work. My data is protected. The intellectual property from the telematics provider is protected, and we can still have the right results. And so this class, there's a couple of different techniques that allow us to do this, right? To work on encrypted data, to work on encrypted models, and still get the right outcomes, right? So I'm going to actually go through each of these categories to show and illustrate what they are. So let's start with secure enclaves. So this is a hardware-based solution. And so in this case, party A and party B first, we have to agree upon what we're going to do. So in that previous story, I would have to agree on the telematics model or the telematics prediction that was happening. And then once we agree on that computation, that software is then run in a secure enclave. This is a hardware piece that is operated by an intermediary. And then that generates a public key that each of the parties A and B then encrypts their data against. And then the software then runs on the enclave on the encrypted data, and we get the result. So that's one way we've done things. And there's certain things that are challenges for this, right? So one, I think the most one is you still delegate the trust to that person operating the secure enclave. I still had to agree upon, this is the actual software. Someone has to implement that software model within the enclave, and I have to trust that they did the right thing, right? They didn't actually throw in some extra compute that I didn't plan for. And then also performance. This has a performance limit on the memory and the computations that are executed. But in many cases, this is programmatic trust. So if you could verify this and you can be part of that group that is really, making sure that these models are programmed correctly, and you might be able to use legal steps to really make sure that happens, then this is a very good solution. Differential privacy is probably the one that you've heard the most about. So in this case, let's say that party C wants to use party A and party B's data for some computation. And so in this case, party A and party B are going to use differential privacy. They're going to take their data and add a little bit of noise to it so that you can no longer see the original data. It's pretty much sanitized. And then we take the sanitized data that has the same characteristics of the original data sets, and then party C can compute and get a result that is shared. And so this clearly has limitations, right? It certainly works with if your use case matches, but it only works with some use cases. The ability to add this noise and still have a meaningful result, it only works for certain types of computation. So there's a limited number of use cases this matches to. And then also there could be privacy breach attacks. So I might actually engineer my data that I submit to party C in a way that I can actually learn, how they're actually making the decision. And so there's challenges here too. So let me talk about homomorphic encryption. And so as I do that, let me give you an illustration of how maturity has come from federated learning, which you might have heard about. So federated learning, so let's say machine learning, typically we take the data, we might bring it to the cloud, and then in a data lake, and then you might actually have the machine learning happen there. Federated learning takes the model and the model that needs to be trained, and you push the model to the edge. So in this case, let's say on my phone, so Google, when they are doing the training for, the autocompletes of the words, right? So when you're typing things and it actually autocompletes you to the wrong thing, that's a learning model that actually does federated learning to figure that out. So it pushes the model to Teresa's phone. And then on my phone is where that training has happened. And only the summary of the results is then pushed back into Google. And so in this case, this is a great first step, right? So none of Teresa's raw data was actually propagated within the data lake. It was just the learnings. And I would say the next step to that is homomorphic encryption. So homomorphic encryption does everything I just described, but the data is encrypted. So even the model that is actually running to learn is operating on the encrypted data. So let me now talk about what this could look like. So party A, it's going to need the results of, of someone else's data, let's say party C. And then party B, just like in the break supply and the telematics screenshots that I was showing, they might have a model that is a proprietary algorithm, right, that they don't want others to see. And so party C can encrypt their data. Party B will have an encrypted model. And only those encrypted results are then shared with party A, and party A can even add its own encrypted data to this. And so to decrypt it, you actually need the permission from all the parties, in the party A, B, and C, right? The person has the model. So here I can actually check that the model that I developed, maybe it's a machine learning model or it's a proprietary engineering model, that it's being used for the right purposes. So things like facial detection, you can imagine that you might want to control exactly who's using that and for what reasons. The data itself that's used maybe to train the model, that's also something that each party has control of. And so only when we all agree that this is the right result, the result is seen. So nobody had to actually be able to even see party B's model. So all their IP is protected, and nobody would see the original data set. So that data is protected. And so, I mean, this sounds super cool. There are challenges. So one is performance. You can imagine running on encrypted models and encrypted data. That's a lot of compute. And so the math for this has actually been around for decades. But with the advance in computing, we can finally do this at a reasonable time for certain problems. And so the performance is an issue. It's typically an order of magnitude slower. There's computational complexity, right? So the types of computations that this works for, it uses a mathematical principle homomorphism, same shape, right? Same shape of the formula. And so you can't do this for everything. You could do this for things like anything you do with SQL. You could do this for things like logistic regression, linear regression. But you're not going to be able to do this for all sorts of other types of AI and ML yet. So that's a limitation. The result and the precision is also something that for some of these algorithms that's a challenge, and it has to do with both the computational complexity and the performance. And finally, the multi-party schemas, right? To do this, we all had to agree upon the data schema and to make sure our data, before we encrypt it, actually looks in a certain way. So sometimes the value, as we all know, is actually in the data itself in its original form. So we really have to know what question we're trying to answer when we're taking this technique. But I think, it still offers a lot of cases, like I mentioned, with the supply chain, with the financial services and the trading, with even being able to look up, right, Teresa across different entities, let's say different government organizations, that this is all talking about Teresa. So maybe that match and that join is happening via homomorphic encryption. And then after they know this is Teresa, maybe the rest of the computations happen in a traditional way. But in this way, that person never had to have a trusted entity to see all the data. And we're still able to wait till we have a good hypothesis that, Teresa's the same person, and then make the case. Now we need to see the rest of Teresa's data because we think she's sick, or we think this treatment would be effective for her. Give us more data. So I think if you think about it as a multi-step, now it makes a bit more sense. Let me talk about secure multi-party compute. And secure multi-party compute is actually a combination of the different privacy-preserving technologies. So if you take two of the different techniques beside this class, this is where you actually have secure multi-party compute. So things like homomorphic encryption, garbled circuits, secret sharing, it's layering these. But multi-party compute looks like this. So you have parties A, B, and C, and we want to set up these connectors. And so party A, B, and C will have that local computing capability in which you could do things like the federated learning, you could do things like the homomorphic encryption, and then you still have the aggregator and the orchestrator that takes that aggregated results and then presents something that's back for the whole party, right? So it's actually layering in some of the techniques that I just talked about. And so some of the same issues, right? So when you're layering it in, certainly you have the benefits that overcomes the barriers of each technique by itself, but there's other issues that might be involved, right? So scalability still remains, performance still remains. Some of the needs about protocol security, like how do you implement this? And there's complexity that remains. So hopefully it's not too negative though, right? I wanted to present a real picture for architects like you, but the capability to do the compute is really what's exciting to me. Like you have all these tools now that you can layer them in. And as long as you keep in mind, right, so and performance. So I'm not going to actually compute the whole machine learning algorithm, but taking the step to say maybe the part that I do first is just the join. Let's do a join that says, take all this different data from the different parties. We're going to join and say, okay, these three people look like, there's something interesting about them. And then let's get the raw data in the second step. These are how you could apply that. So I'm going to end with one higher level story about trust, right? So I hope you're excited. I mean, I think I'm pretty excited by this new set of technology enablers that will allow us to look at programmatically protect data, its use, models, its use in ways that hopefully will alleviate the fears from consumers, alleviate the fears from enterprise. But then at the end of the day, right, it's really redefining collaboration and trust. So in that financial services story that I told in the beginning, today, again, I'm trusting this sort of money manager, right? I need to tell my money manager pretty much, you know, he knows a lot of things about me, right? He knows how much money I have. He knows my ambitions, like if I want to buy a yacht or if I, you know, am in debt and things like that. And he today, especially for high net worth individuals, these people, they call, like they just know people and they call, they're like, oh, I think Marnik also, he's selling yachts. So let's make a connection, right? And if he didn't, it's really depending on this person, like the money manager, to make the best choice for Marnik and myself. And sometimes they have our best interest in mind, but you're actually putting a lot of trust on that other individual. So if we have this technology that now allow, you know, these, you know, some of our secrets to be more ours, or control over the data as to who I want to know that I'm in the market for a yacht and what I want to pay for it, or that Marnik is selling a yacht. I'm sure none of you know that, right? So I think all of this stuff we can actually think about programmatically, maybe replacing that role of the money manager, right? So we have a trust sort of capital that says, you know, there's relationships, there's people who provide data that produces outcome, people who provide models that produce outcome. That's a different sort of trust that we're enabling, right? We're actually allowing these companies to now compete on their data, to compete on their models, compete on their trust. So hopefully this gives you a taste of this new technology. I did want to see if there's any questions.
All right, I'll jump right in. Thank you very much for the presentation, Teresa. And I'm super pumped to be in the yachting business. I always wanted to be in the yachting business. I want to own one. And now I heard that through this technology, I'm able to. So thank you for that. Someone says, it's not really, there are questions coming in. Someone said, I don't think it's really the first one a question, but someone says PPC sounds like mirror, mirror on the wall. So.
Sounds like magic, right? So I think I suggest you click on the link of the point of view that I'm sharing, right? So the math has been around for a long time. Accenture has actually open sourced a library called PyHeal to do PPC on via Python, and it wraps something called Microsoft Seal, which is the Microsoft C++ library for the same. And again, it doesn't happen with all types of compute. It happens with some. And as I mentioned, I hope I was honest, it's slow. But for things, let's say voting in the US, I don't know if there's a show of hands, but many people don't want people to know who they're voting, Trump or Biden, right? So this sort of thing would allow us to encrypt this and still get the right answer. It could be for things like I mentioned in the addition. So you can imagine things like if we all agree and we generate a random number as to what we change our addition factor by, and then we can sum it together and then remove the noise. We still get the right answer at the end, but then you've removed the noise, and you never knew who actually contributed to the original numbers. So I think these are things that you could kind of imagine how it could work, but I suggest you read the papers. It'll tell you how it really works.
For the rest, applause is coming in, so everybody's clapping. This is good. People are asking for the recordings. So they probably want to watch it again. I have one more before I go. And it's also a question because I'm also allowed as a host to ask questions. I do it with every speaker. Tell me if this is a really dumb question, because like I said, I don't have the same background as the audience. So please be honest. But yesterday we had a panel discussion and we were talking with Jack Ramsey. I don't know if you know him. And he said that talking about this security in data, the trust between the people, the technology, the businesses. He says nobody's talking about it, but there's a big risk when the quantum computer is really there, up and running, and it's really a thing. then nothing will be secure anymore. I don't know what your opinion on that is, or what's your vision, or it's maybe a stupid question.
I work with quantum computers as well. So the breaking in of encryption, the factoring of two numbers, I think that's 10 years out. So the types of quantum that are 3 to 5 years out are things around something known as annealing, simulated annealing. These are things that solve optimization problems, right? So things like for planning logistics, right? So your trucks and where it's going to go. So anything you could write as a optimization logistics problem, that'll happen first. The factoring of two numbers, the size of the quantum computer today, the biggest number it can factor into the primes is 15. So we can all do that, right? I hope. So I think we're safe for the next decade.
All right. Okay, Jack, we're safe for the next decade. If you're watching. All right, I'm checking real quick because our time is almost up. People, a lot of applause. So I'm just giving you that. If you don't see it, it's always fun as a speaker to know. Definitely in online what feedback that you're getting. And also people are going to fill in the polls about the presentation. So I want to thank you also from the audience. Thank you very much, Teresa. And I don't know what time it is right there. Where you at?
Oh, no, it's okay. It's 9:05. But I brought you guys right back on time.
All right, cool. Thank you very much. Have a great continuous of your day, and hope to see you physically next year.
Next year, yes. Thank you. Take care, guys.
Bye-bye.
Yes.
All right, Teresa Tung. And the next speaker, if I'm looking at my backstage, is already there. My crew is not really my crew, the OpenSlava crew, is telling he's super pumped and seeing what I saw of him online. I'm not going to make the expectations too high, like I said, but I want to give him the nice opening. So I'm also super pumped to see this. And before we go there, I just want to stress that it's really cool that we have been talking about so many different things, and we have also been talking about the security part. I just said about the quantum, and I think it's also really cool that in OpenSlava that we're talking about the technology and we're trying to make everything as sustainable as possible.
Our cloud solutions are intentionally designed for a positive impact on your business and the world. Learn how you can meet your sustainability goals.
All right. Saw what I did there. Nice link. There you go. Everything's sustainable. Like I said, sustainability in the technology, but also sustainability in what we are building. Like I said, next up, the speaker's already here, and don't take much time of him. And his name is, and a lot of people, I'm also going to say this, I'm talking about Jesse Warden, and a lot of people said in the beginning they're looking forward to this one. So not pressure on you, but people are already excited to see you. So if you're there and you have questions during the presentation that you want me to ask Jesse afterwards, put it in the chat. Definitely let us know. So I'm talking about Jesse Warden. Small introduction for the people that don't know him. He writes software. It's simple as that. He writes software at Capital One. If I give it, he has 20 years of experience as a software developer. I read what you did, Jesse. It's too much to mention. You did it all. You transferred. You evolved. It's amazing. I'm not going to mention, but you have the 20 years experience. You write code front, back end, and you like deploying it on AWS. You look a bit like Johnny Cash. I hope that's a compliment for you. Checking him, you can't see him in the audience, but he's looking at me. I don't know if that's a compliment. You look like Johnny Cash. And you're a man of many skills, and I think the best way to sum it up is that they just check your blog, because you write so much about the software that you're writing on jessewarden.com and on your YouTube channel. And you're going to talk about us today about using serverless and functional programming for ingesting Meteor price data. All right, and I want to do you something special with you. I saw your YouTube channel, and I'm going to introduce you as you introduce yourself on your YouTube channel. So I'm going to do, you forgot to take it offline. You forgot, he's going like, oh, no, not that. So I'm going to do it. And after that, you can take the virtual floor and do your thing. So this is the introduction. Here we go. Jesse Warden, programming, gaming, fitness, Jesse Warden. Take it away. Virtual floor is yours. Have fun.
I appreciate it. All right, so I use the word meteor, but it's really about actually asteroids. I don't know. I like meteor because it sounded more fiery and more impressive than rocks in space. All right. So, and like I said, if there's any questions in the middle, I don't mind you stop me at any time and ask questions. I do not have to wait till the end. There's a lot of this is beginner material. Some of it's advanced material. Some of it's very outside material. So do not mind stopping. So what we're going to talk about today is building AWS Lambda applications. And I call them serverless applications, but AWS calls them Lambda. And we're going to use an example ingestion of asteroid price data because there's a lot of data, a lot of parsing and moving around different data sets from different sources. Some of them have a lot of technical debt. Some are very slow. Some are large. Some are just bad data. And parts of that example are showing how we can build a AWS Lambda application and really think about the error handling part of it. And so that's the main part I want to cover is error handling, the skill tree about leveling up. And it's not just about leveling up to the top. It's really important to know each one of these levels so that you can use them in different situations. If you're using level 1 to learn things, level 6 when you're deploying a prod, things like that. So my name is Jesse Warden. I'm a software developer at Capital One. I'm forced to use Python and JavaScript. I don't really like them, but I use them as a job. I would prefer to use functional languages, but it's a minority in the job market. So I just keep trying to lead by example rather than be a wizard in the tower. So when we talk about asteroid prices, what do we really mean by asteroid prices? If you think about by 2080, it's estimated that Earth will run out of natural resources. And it doesn't mean they're all gone. It just means they're really hard to get. And asteroids have a lot of precious metals in them just because the smaller ones, it hasn't sunk to the core. So it's a lot easier to get at them. Some of them are very pure, but it currently costs too much to get them. So that's why a lot of scientists aren't very excited about it. The rest of us who don't really know much about mining actually are, because it seems really awesome to get 20 billion tons of gold, for example. But if we invest research into it, it actually could be viable. And to give you an example of it, the sands in Alberta, Canada, back early 2000s, it wasn't really, it was messy. It's just a bunch of sand to get oil out of, and it wasn't really viable. But then as soon as the oil price shot up, and there's a lot of horrible political, economic, environmental, and human impacts, it was still viable because profit was there. So if you think of asteroid mining that way, suddenly it's not something we can do, but yet as soon as we run out of resources, we'll find a way to do it. And so that's where your motivation comes from. So if you give an example, this is Eros, where we sent a robot to land on it. It's estimated that it has 20 billion tons of gold and platinum. And if we were to bring that back, it'd be, let's say it's all gold. It'd be worth like 1 trillion euros or about 1 trillion USD. That's insanely awesome. Who wouldn't want that much gold? So suddenly you start thinking about these numbers and estimate how much it costs to get rockets and things to get there. Another example, although it's a dwarf planet, we can lump it into asteroids, would be the Ceres. And this thing is smaller than the moon, about a fourth or so, but it's like 50% water in theory. There's debate if it actually has a metal core. And so we could go there, get metals, but not only that, we could stay there a while because there's water not 500 clicks away. And it's estimated there's about, currently 1.9 million asteroids, but there's probably a lot more, at least we're talking specifically the belt right outside of Earth and Mars. And so there's a lot of opportunity to get metals that are, in that general area if we have a way to quickly travel and target the ones we're getting. The Expanse TV show, completely based on this concept where Earth has pretty much trashed itself and Mars is trying to build itself. And both of those planets leverage these people who live inside of the asteroid belt to get these resources for them. And so that's what asteroid prices are, is about taking these asteroids and understanding how much they're worth and how much it would cost to get there and bring that back, or go there and mine it and bring it back, or go there and mine it and process it and bring those materials back. However you do that, that's what we're talking about from price data. So from an AWS Lambda application perspective, it feels a very weird niche between monolith, serverless, distributed monolith, microservices. It's a very strange term that doesn't really attach itself to those particular places. So I wanted to go over what I think is a really fun way to build them. It's really about services being grouped together. And it's okay if your service is a single app. It could be a single Lambda, which is a Lambda-lith or a monolith being a one Lambda. It could be a bunch of Lambdas, an S3 bucket, a bunch of step functions, a couple SQS queues, some DL queues. a few Dynamo tables, strung in there. It doesn't matter. The point is that you have a single embeddable unit, single deployable unit that you could still independently deploy things. And you can use SAM, the CDK, the CloudFormation CLI, it doesn't matter. But the point is you have a single thing. So when we're talking about building serverless applications, or what AWS calls Lambda applications, think of it as a single unit and a single monitor repo. And there's some advantages and disadvantages of that. What value it provides is that you still have 50 tabs open to see all your stuff on console. But the point is that a lot of them will link back to your app. You'll have a single place, a single tab to start from in the beginning of the day. And so it's a little easier to manage, all your stuff spread out all over the place from Amazon, because it's nice to have small deployable units, but keeping track of them is just really hard. And so if you want to visualize it yourself, you can go into the AWS services grouped into a unit, go into the AWS console for Lambdas. Most people go here and filter. They're looking for their services, some other services. If you're in a shared account, it's really worse. Mine, my particular account is like in the thousands and takes forever. But if you look on the left there, you can see that thing says applications. So when you click that, that's what loads whatever application or applications that you have for your particular AWS account and what you've deployed. And when you click those, it actually gives you a list of everything in there. It's not just Lambdas. It gives you your S3 bucket, your step functions, your Dynamo, everything. It shows what deployments were done and what rollbacks were done and things like that. And it also shows a single place to monitor it. And you can tweak, what the charts are showing up there. It's still not as cool as like something like Datadog, for example, but it's getting there. And so it's nice to have a single place to see all your stuff, what inline, IAM roles and policies are there. And then when you click those Lambdas, they know that they're attached to this app, so you can link back. It's a really nice, user experience from a developer perspective. All right, so that's what AWS applications are. They're just all your existing AWS stuff you're deploying in a single place. Let's talk about the main part of this prezo, which is around error handling for putting those things together and wiring them together and debugging them and feeling confident what's wrong if they go. So this is just something I made up to feel smart. It's not formal at all. It's just from my experience of seeing the different levels of error handling, and each one is not necessarily better than the other. It's more about appropriate use, but I still feel like I would love to live on level 5 and 6. But one is basically ignore them. That's what dynamic languages are really good at. You just quickly compile, run, go, run your code. Level 2 would be like try, catch, throw. So if some areas you don't want to know about, like analytics, if it breaks, you don't want to know about that. Just log it. Like, I don't care. It doesn't affect the app. So you would still catch that, right? But there's not much you can recover if you can't load data. Go and Lua style, start treating functions as did they work or not, as values. Pipeline styles, when you weld all these things together, and at the end, either success comes out, or if any part breaks, an error comes out. So it simplifies the error handling for that. And it's a lot easier to follow that imperative style of what's going on. And then pipeline style leads to pattern matching. So once you bring types and different outcomes, you can pattern match. And it's a more powerful way of doing if statements and error handling because they come values. And so this is kind of a slow overview. We're not going to cover the entire thing in this prezo just because I don't really have enough time it would take about 3 hours. But the point is we're going to get a bunch of data around asteroids and munge them together from different satellites that the Jet Propulsion Labs from NASA, they actually offer. And some of those satellites no longer have any fuel left, so they're up there floating, not collecting data, but we still have the data sets, and there's actually other new ones. So we're going to pull that data together, merge it together, and then at the end, put that in the Dynamo from an active perspective. So that's kind of the high level what we're trying to accomplish with these 4 or 5 Lambdas. So I'm going to cover the Lambda basics because this is something that it took me 6 months to really get what AWS wanted me to do. They didn't really provide a lot of guidance in terms of developing for these things. They use terms like function. You're like, oh, I know what that is. And then you try to deploy an Express app to Lambda, and it's like, well, it's stateless. That doesn't really make sense. And so I wanted to cover these things because I thought they were just so fundamentally important. It bears repeating. So they're based on Lambda calculus, which basically means one input, one output. And if you have a function with 2 outputs, you have to nest them, very similar to Lisp or, lots of parentheses. So it's a function. It's not a microservice. So if anybody says you're creating microservices, it was because this was popularized by REST developers who link these things to APIs. But not all of us are linking Lambdas to REST APIs. There's a lot of different triggers that can make these things happen. And AWS manages it. So all you focus on is writing code, which is why it's so amazing, which is why I'm awful at DevOps. When I'm in interviews, yes, I'm full stack and I can do DevOps and Jenkins. But when I'm not in interviews, I'm like, I hate it. I would rather somebody else manage it. So when we talk about a basic Python Lambda, we see the function has an input, which is the event. And that in a dynamic language is great because you don't care what it is. It could be anything. That's what's so wonderful about dynamic languages. When you print that event, it immediately goes to CloudWatch. So you can use your native, prints or console.log or whatever. And whatever you return, that data goes to whoever's listening for it. So those three core concepts are extremely, extremely important because they build on everything that it really offers. And when you think about triggers or invocation of a function, it's anything on Amazon. It could be API gateway when somebody types in a URL to a browser. It could be S3, somebody drops files on a bucket. The event bridge, which is like the new event bus. It used to be in CloudWatch. They all give you different JSONs. That event's completely different JSON. And the cool thing about dynamic languages is that you just can read from it maybe or not. And if you want to see what they look like, AWS SAM allows you to generate these for local fixtures. So if you just want to unit test or just play with it. But the point is, at the end of it, the Lambda is supposed to either work or not. But there's a lot of nuance there about if it works or not, because sometimes it doesn't return a value. It blows up. All right. So when people got first into this, they said, how do I run AWS locally? And they would immediately reach for Docker. And the last thing I ever want to do in my career is reach for Docker or CSS. And so this kind of concept of running your code locally it's just your code. It's just a function. So Python, you literally write your code. And then at the bottom there, you can see that if name equals main. That's a way for Python to run when you go Python the file. But if somebody imports it, that code won't run. So you can put it in Jenkins, you can put it on AWS, and your code will never run. That's just for you to play with it locally. And if you run unit tests, that code won't run. So it's a really nice way to run your code locally. And what you're running locally runs the same way in AWS. So it makes you have a lot of confidence. It's very fast. And same thing with JavaScript. You can name that stuff on the bottom. And you notice like the event, I give it as just an empty dictionary, and JavaScript case an empty object. So a really simple way to play with these things. They don't have to be these complicated gigantic build systems. You don't need Docker to run this stuff. And from a unit test perspective, as long as you're not using any third-party dependencies and start using dependency injection, you don't even need mocks. So you can just run PyTest or Mocha or whatever and unit test your Lambdas with the JSON input and whatever the heck you send outwards, right? So that's from a unit test perspective. So let's cover Delta V. Delta V is how much velocity it takes to get something in space or turn in space. And we're going to use this as an example to show level 1 and level 2 error handling. And if you think about delta velocity is really going in a straight line and then turning, that's really what it matters. It's not about the size of the rock or whatever else, because once you know the delta V, you can start doing, all right, how much does it cost to get to that big rock in space? And then you either mine it or bring it back. That's what we mean by delta V. And if you look, there's a lot of different types of tables and CSV data out there. But at the end of the day, they have what the designation is for this asteroid, because some just don't have names. And so these binary equations are an example of the different asteroids, near us, really far away. Some are extrasolar, they're actually like outside beyond Pluto. And what is the delta V that it costs to get there? And then some of them have masses and makeup of the asteroids, so you can kind of do a reasonable projection of what minerals do they have, what value do they have? Do they have gold, platinum, what silicon, what's there, right? So we're going to parse that particular table, and these are occasionally updated. So we have a URL, we open it, and we get the data back. That's a string. And so right now we're just trying to test and see this code run, and we don't care. There's no error handling whatsoever. And then once we get that string data and print it out, we verify it, we can parse it. And so that parsing, all it does is extract the actual CSV table data into a CSV file, because we don't care about all the rest of the HTML around it, right? So once you have that, you can throw it on S3, and then later, S3 is like a hard drive in the sky, if you don't know. You can take all that data that you're going to parse from the hard drive and then munge them together later. And so S3 is a really wonderful way to store files, read them later, massive size. And if you don't have a database, it's a great, quick way to get things done. And that last thing is really important if you've ever done any eventual consistency on S3, because it helps you actually have the hash of the file. So if you have to read it, you can verify you're reading the right one. So there's a lot of things that can go wrong in this function. You're reading a URL from some third-party jet propulsion website, you're parsing CSV data, and you're assuming that you have access to go to some random bucket. There's a lot of things that could possibly break here. You don't have a guarantee that e-tag exists on that dictionary. A lot of things that could break. But what we're concerned about really is what's your fault and what's their fault. Because what's their fault could be retried, could be caught, could be tried again, right? Sometimes there's other things you can do about it. So what we're interested from level 1 and level 2 is really just try catching on the things that aren't our fault, so we can signal to others that, hey, they should probably try again. They might have to wait a second, but that's that point. The bottom stuff, if it breaks, you want to fail fast, you can fix it, and that's cool. So we're talking about errors. If you're a functional programmer, think of these as types, okay? I know that using exceptions is blasphemy, but if you're an OOP or object-oriented programming or an imperative developer, these are custom errors that allow you to signal in a language, their fault, my fault, right? And that way, those who consume you know what to actually do, what kind of action to take. So in Python, you just literally make a class that's passed, and JavaScript, you just extend the error. And we're going to wrap that one with a try catch, so we get the result of it, but we're going to raise a very custom exception for HTTP failure. So that way we signal others, that's not my fault. If you would like to retry, go for it. Everything on the bottom, dude, fix it. Like, it's literally 3 lines. Now, you look at this code, and this is just a point around microservices. A lot of people think, why would you want to have many lambdas rather than a lambda-lith? If you're learning serverless, lambda-liths, monoliths are great. They are the best way to learn. That's the way I learned. Once you start realizing that whether you're using serverless or using servers or whatever, code does this thing called grow, and you cannot stop it. That's why a lot of these old crusty developers say, I love deleting code, because it's impossible. It's impossible to delete code after a while. So what you do is you start small, and you guarantee they're going to grow. You can't stop it, but at least they don't get so big because you started small. So this 4 lines of code already has grown to like 6 or 7, right? So anyway, that error is important. Using step functions, a lot of this serverless stuff became very, very difficult to orchestrate, to call, and it was a lot of just very indeterministic stuff. If you ever looked at all the reactive architectures, they talk about event-based architectures, event sourcing, CQRS, and it's kind of like you light a fuse and it just kind of runs on its own. There's like no way to control it, and everyone lauded this as a wonderful way to build apps. But as someone who's has control issues, I loved the concept of orchestration, and that's where I fell in love with Node, because I would go into these companies that had all these APIs, and we would use Node to kind of orchestrate what we needed for the front end, or just make a new API that was the data we wanted, versus waiting 6 months for somebody to make a patch, right? And so step functions were kind of created to orchestrate all this stuff, but in a very deterministic way. And so that's why I love it. So we're going to use this to illustrate why that level 2 of try catch can really help here. So if you don't know about step functions, they are my favorite thing in my life for the past 2 years. They're mostly a finite state machine. Finite state machines are what we all try to do in programming. Like, it either works or it doesn't, but then we have this third thing that magically appears where it doesn't. And so that's why step functions also kind of do that, because they don't have the best error handling, but they're getting there. You write in JSON with some inline functions. It's called JSON path. So it looks like JSON, but it has a little extra set of features, and AWS has pared it down a little bit. It's made for orchestrating things. So lambdas, batch, servers, message systems, whatever. It's supposed to be the dude who controls all of it. And but the reason it has a function in its name is because it takes an input and has an output, just like Lambda functions. The real reason a lot of us in big companies like it is because of the catch and retry with exponential backoff. Anytime you're technical debt, sometimes systems go down, you want to retry and encourage that it doesn't break your system. You have blast radius protection. And so these 2 features are what really is really compelling about step functions. And it can run for a year, and that's good and bad. You don't want to know your code's broken for a year, but that it's compelling because the point is I can wait. I don't care how long the server's down for, I can wait. That's the compelling thing about it. The nomenclature, just a quick review if you don't know, execution is when you invoke a step function, it's running. So if you look at 5 times, you have 5 executions. The input is either string, JSON, whatever. As long as it's JSON supported, you can make that as an input and an output, okay? The output is whatever comes out. And it could be a bunch of lambdas that mangle stuff, could be a batch, who knows? The definition is what is the JSON that makes up your step function. So when you say like, what's your definition? It's like the JSON that illustrates this visual step function. State is any one of those boxes that you go through a step function, and the transition is going between those boxes. And so when I say state, like the step function manages where it is, what function's running. You don't have to manage any of that stuff. So if you're a functional programmer, this should make you so unbelievably excited. If you're OOP developer, you're like, okay, whatever, which is fun. Data is the JSON that travels through, and they have a lot of powerful ways to tweak it. So this is a basic step function. If you look to the left on that definition, you can see that it has a type of pass. That just means cool, it worked, and the result is whatever you return. So to give you a visual comparison, if you were to write this in Python, you can't currently, but it'd be so awesome if you could. If you look at the left, it says, I have a state of hello cow, and I'm going to return to this value. If you were to write that in Python, the input would be whatever you invoked it with, and whatever it comes out with is the output, right? And that's generally how it works. And while you can create your own executions, step functions are just like everything else in AWS, especially Lambdas, that you can invoke them with other services. You can use CloudWatch, you can use S3. So very similar triggers to launch and invoke Lambda functions. Step functions can be invoked the same way. Sometimes they can invoke themselves. You can do recursion with them, which sometimes helps if you're running low on event history things. And so you can see the wonderful thing about step functions more than any other infrastructure in AWS is that they have built-in monitoring. You can very quickly say, oh, this worked because it's green. You can look at that one and go, okay, it worked. You don't need Datadog or monitoring or dashboards or SNS topics. Like you just immediately can see it worked and click on it and see what the input and output is. So it's a really nice way to view, did your code work or not? I wish a lot of programming environments were this transparent. And the input, you can see what your step function took as an input and as an output. So very similar to functions, you can see what it came out with, because a lot of times this stuff will change drastically based on what services you have in there. Now, if you have two of these states, think of it as like functions calling functions. Step functions will orchestrate that calling for you. They'll orchestrate, passing that data. If you look at the bottom, we have an intentional one called fail, which is almost the same thing as raise in Python or throw in any other language where you have errors. And it'll handle those errors and show you those errors and let you know if it worked or didn't work. And so you'll look at the code off to the right. It's kind of to illustrate how it would work if you were to write it in Python. Again, you can't do it currently, but it just helps you visualize how they actually run from a programming perspective. And so here it's cool. Did it work or not? No, it broke on Hello Boom. How many fire drills have you spent 5 minutes trying to figure out what's wrong in production? Where here it's like, oh, that broke. Like you can immediately see it. It's so great. And if you click the exception on the bottom right, you can see what exception it threw and why it broke. And you can oftentimes have a direct link to the CloudWatch logs for that particular service. Could be a Lambda, a batch, whatever. So really, really wonderful way when you're failing fast to very quickly see what went wrong. So we're going to wire this up to an actual Lambda function. This is going to wire up to the download binner equations Python that we just wrote. And it's going to utilize that error to handle the fact that if it doesn't work. And so here we're running it. You can see that they're asynchronous by default. So all step functions can take as long as you need, up to a year to run. And if you look at this one in particular, it's blue, and that means it's currently running. So we're waiting for that Lambda to go to that website, download the data, and parse it. And when it's done, you can see that the output is that hash that we returned from the Lambda function. So the step function can get those return values of whatever your service is, not just Lambdas, but anything. And it's there. And I think the cool thing is if you look at from an end-to-end test perspective, because you're not really going to unit test step functions. You could if you wanted to. They have I think it's a Docker container you can run locally, but anything that has, Docker in it, I'm like, peace, I'm out. So in this case, you can just run, Python behave test or a Mocha test or whatever, and do an end test and functional test very quickly for your step functions. You treat them like a regular function. And so I've kind of got if you look at that output there, that start and wait, it's just a wrapper around, waiting for the execution to run. But you can treat it like very functional programming. I have a function, I give it an input, I assert on the output. So really, really cool testable way to do end-to-end tests. And if you're going to do a bunch of these, I highly encourage you to do the async version. So if you haven't done async IO in Python, it allows you to run a lot of these things concurrently. End-to-end tests, even to this day, still have a bad reputation for being slow. So anything you can do to speed it up and do, running a bunch of step functions at once, then use the async await syntax for Python or in Node, whatever you're using. It's just a minor way to help speed up a lot of your tests. So retries is one of the main things that if you're an enterprise developer, you fall in love with, because you're dealing with either, cloud migration projects, mainframe migration projects, or just a code base that's been around for 15 years, had a series of contractors, and nobody loves it. And so it has nothing but technical debt. It always breaks and no one knows why, but sometimes it works. And so retry can help with that. And so if you look at errors equals, you can think of that as like when a try catch, you can put as many error types as you want in there. I just put states all, which basically means any error ever, right? Interval seconds means how long are we going to wait? Like if it breaks, we're going to breathe and then try again. Max attempts is how many times are we going to retry? So a lot of times at the enterprise, that's going to be 3,000 because things break forever. But 3 is just an example. Back off rate is how long do you slow down? So at first you wait a second. Oh, maybe we're getting throttled. Okay, let's wait 2 seconds. Man, that web server is really overloaded. Maybe we should wait 3 seconds, right? Or 4. So that back off rate is exponential. Over time, it'll multiply that by the interval seconds. And I built a calculator for this math because I'm horrible at math. So it helps me visualize this. So we're going to put that retry, and I'm going to manually hard code a URL as like cow or something. And so that way you can see that error from that Lambda and then retry multiple times. Now, if you look, it says it failed, and you can see that the exception, but we don't know how many times it did it work? Like, is there any way to see what it did? What's the visibility? So if you scroll to the bottom, you can see something called the execution history. Because it's a finite state machine, it has very clear steps to go from state to state, those transitions. It's very deterministic. And so you can see, if you look at those numbers, that it tried, failed, waited a second, tried, failed, waited 2 seconds, and then again waited 8 seconds. And so that math is kind of done for you. It's not exact because there's some latency in invoking Lambda functions, things like that. But you can see that history there of exactly what happened. And each one of those steps shows you as your JSON and data changes over time, if there's any errors and if it recovered. And all that state of like trying again, that's all managed for you. You don't have to code any of that. And like step function has no server, so it doesn't like go down in the middle of this stuff. It's really, really cool stuff. All right, so that's level 1 and 2. Try catch, looking at it from a step function and retrying. Let's talk about the Go style, which really, I think, revolutionized a lot of people's thoughts about error handling. If you don't know about Go, it's just what it does is it doesn't have classes, it just has functions, but it returns multiple values from a function. And the convention is that you return true. The first is an error, if you had one. The second is data, if you have any. And the caller of that function checks, is the error not equal to nil or none or null and undefined, right? If it is, it immediately returns and stops. And so what this results in is code that's very imperative that you can read, and all functions do 2 things. They either work or they don't. And that's it. So when you combine a program made of functions that work or don't work, then your program either works or it doesn't work. And if it doesn't, you can very clearly find it, very similar to a stack trace, except in this case, it's like a line of code in a function. And so error handling in Python supports this style very easily because of the tuples and destruction abilities that it has when you're calling them. So if you look at trying to do that style in if you use like MyPy, for example, for types, it's up on the top right. You can see the tuple has an exception or anything. You return a tuple with 2 values, and the errors first, if any, or the value. And then same thing for if you have an error, you just return the exception first and then nothing for the second. People consuming it literally destructure it. You get those 2 values from that function, and your code in Python starts to look eerily similar to Go. The types aren't as powerful, obviously, but it's very clear to follow. So people who like imperative programming and like that Go style of error handling, it's nice because then all the functions become a lot easier to test because they're just, asserting on values, inputs and outputs. So if we go from an exoplanet perspective, where we're downloading even more data, that download function either works or it doesn't. It could be it downloaded it, or it could be it downloaded it, but it couldn't parse it, right? Whatever reason it is, that's their fault. It's not my fault. My fault would be trying to upload it, trying to parse it and things like that. And so we have 2 distinct errors, their fault, my fault, and we have a way to actually do that from a type perspective. So HTTP error, go ahead and retry. General error, fail early. There's our code's busted. Deploy. And so a lot of what you're going to do with these errors is like, okay, but how do I interface with code that I didn't write or doesn't follow that style? Well, you have this thing called try catch or try except. So everything can be wrapped into try except, and it's very clear if the function worked or not. And the AWS SDK is amazing at this because they follow the Python methodology of raising exception if it doesn't work, or returning the value if it does. So it's really easy to integrate from that perspective. Now, when we talk about let's see if I want to do, parallelism. So parallelism, I can't pronounce the word, so go ahead and make fun of me. It basically means doing many things at once. And step functions have two ways to do it. And the reason that's important is if you've ever done asynchronous code, sometimes you need a bunch of things to happen at once, and there's no reason they need to happen in a line, right? They can all happen at the same time to get data. And so a lot of our media data or asteroid data is pulling from different data sources all at the same time. And we don't really care what order, we just want to wait for the end. And so step functions allow you to do that. Now, if you've ever done like, let's say promise.all in JavaScript or the async await syntax with gather in Python, they do all those things at one time. And at the end, they guarantee that when it's done, they're all done. And they gave you an order that you added the data that came back. So it solves a lot of that really hard asynchronous problems for you. But it doesn't handle the retry and things like that, which the step function does. So if one fails, it could possibly succeed if you were just to wait, right? It's not fair that one dude broke everybody else. And so it doesn't really have that kind of stuff built in, where step function parallels do. So if you look, you can see the retry tag in the top and bottom one. If any of them fail, it attempts to retry again. So it really helps increase the likelihood that your code's going to work simply by just retrying, but still handles, all the async things and all the weird, asynchronous issues you could run into. And so it looks like this. It's basically a single task. Each one will get the same exact JSON input, but at the output, it's going to be an array, just like you would in Python or JavaScript. And so that array has the data that they returned. And using the JSON tools, that set functions, you can, mangle and play with that JSON as it comes out if you need different data types. All right, so now that you understand the basic of error handling from try-catch, throwing errors that others can determine, what do I do with this error? Is this my fault? Should I retry? Pipelines really help simplify a lot of what your Lambdas are doing, even if they're doing many different things, into either it worked or not, because you're composing these things and you're going to do the same thing in step functions. So pipelines mean like a lot of pipeline-based program or railway programming is popularized in F#. At the end of the day, it's very similar to Go. It either worked or it didn't. And so result's a very popular one. Functional programmers call them either, but nobody can remember what's the difference between left or right. It's a stupid name. I don't care what anybody says. So result's better because you know if it worked or not. Succeed or failure. It's very clear. And so it's like the Go style, but you can chain them together. So you don't have all this imperative, like if it worked, return, if it worked, return. Like it handles doing all that stuff for you. The bottom line is there's no manual checking for error. You don't have to write all that. So if you think of I think it's called dry Python /returns. It's a library that makes a lot of this stuff a lot easier. There's two ways to do it. You can either manually do it with the try except or try catch way of doing it, and then return that success or failure. Or you can just put the at safe decorator annotation and it handles all that for you. So it makes your code very safe, either it worked or not, and it's always going to return that. And then you can pipe them together. And if you think of creating each function as a single input, single output, you create these like pipes or connections together and it just flows right through. And even more amazing is that if you use MyPy, you actually get strong typing on what those results are as they change between data types, between functions. It's a really, really cool concept. So not only you get strong typing, but you actually know what the heck's coming out of 15 pipes that you wired together. And again, error handling is in one spot. Okay, so functional programming is cool and you get these results out, but that's not what step function speaks. It speaks JSON or errors. So there's this thing called unwrap. So if you use the unwrap function, it basically says, all right, here's your data or explosion, right? And if you did the right explosion, actually inside your failure, then you can actually strongly type on that in your step function for your error. And so a lot of people also look at these pipelines and go, wait a minute, what if my function has more than one parameter? Well, if you use partial applications, you can pre-fill those parameters ahead of time. And I think the Python actually has a lot of this stuff built in now. You don't have to use like curry and all that other insanity. So Node.js streams, very similar concept. If you have cyber concerns like I do, where a lot of security, where we're reading files that are either bigger than 500 megs, right? Bigger than Lambda allows, or they're like gigs and they're bigger than the memory that Lambda has. And you're not allowed to write it to disk. You can't even write it to like EFS if you mount that to your Lambda. Then cool, stream it. And stream is the same way. You have these pipelines, they have errors, and it's in a single place. And they either spit out, I worked, or they spit out explosion, and here's why. It's my fault, their fault, some downstream system, whatever. And so think you still have the same API that comes out of those pipes. So there's another way to do concurrency though. And this is probably one of the second most powerful things about a step function when you're dealing with systems that you have to obey SLAs or service level agreements, where you have to, call maybe 2 TPS or 1,000 TPS or respond on a certain time. It's like a for loop, but it's all at once. So instead of parallel getting a copy of all the data, each state will get its own item of the data. So it could be any state. It could be a Lambda, a batch, another step function, whatever you want. And each one of those items is given. What you spit out comes back in the other array. So if you know anything about functional programming, like a map, for example, a map is, it's going to call that whatever function you give it for each item in the array and replace that index in the exact same spot with whatever you return. And so that cook could be a Lambda function that takes that data. It could be a batch. It could be anything you want. And it's going to create a bunch of those. Now, generally, that's kind of cool that it does that. The problem is if you have, like, let's say 400 items of these 400 asteroids, if we load from the JPL database, there's 250,000. That's a high write capacity. You're looking at like $32,000 a minute in Dynamo if you set your write capacity that high, right? So instead, you can set the concurrency to a lot lower. And in promises, like in JavaScript or in await, there's no way to do concurrency limits. I think JavaScript Bluebird has a way to do it, but like if you have 1,000 things, it's going to run all 1,000 at the same time. There's no way to run 3 at a time or whatever else, right? So from a concurrency perspective on that, you literally set Mac concurrency. And that way, with a single item, you can say 100, it'll only do 100 at a time. If Dynamo starts giving you a hot partition and you need to retry, which they actually encourage, or you're doing active, where you're doing conditional puts, right, to Dynamo, and it's going to run right to both regions. Sometimes that's slow. And so it'll, have the retry built in for you. So step functions manage all of that. It'll do 100 at a time, never go above that. And this really helps for, Dynamo, downstream services, whatever. And so if you look, although you would normally write a Lambda function for this, I'm actually calling Dynamo directly in the step function. And it's going to create 100 or 1,000 of these write single asteroids of Dynamo, but only run 100 at a time or whatever your max concurrency is. So really, really powerful, awesome feature. All right, so level 5, this is the last error handling level you can get to beyond going to state monads, but we're not going to cover that. So pattern matching error handling basically means the world isn't black and white. Like not everything in the world is I worked or I didn't. Sometimes there's like, dude, I worked, but like the data's, the same. There's no new asteroids in the past 5 seconds you ran, crackhead. Or what if NASA's servers are down? Like I can't even run. Or my cache was invalidated, I have no data. Or Dynamo's down. Like you have the data, but you can't write. These are actual things that can happen, and they're not errors. They're just the fact of life. So you type for them, right? So instead of raising and thrower, you can use compilers to help with this kind of stuff. So for example, in Elm or Rescript or any other type language, even TypeScript, they have types that define what are the things that could happen. So if you think an object allows you to do any property, a dictionary allows you to add any value you want. Types are the opposite. You only have 4, and that's it, right? Or only these. And so you can do it in TypeScript too. It just takes like 4 slides, but whatever. If you look at the pattern matching, you can guarantee that like a switch statement, if you think of a switch statement, it guarantees you don't miss one. And so these are the types of things that could happen. A server's down. I don't have any new data. The Dynamo's down, whatever. And these are like known things we look for. Now, obviously, we don't want Dynamo to be down, and we hope it would retry, but that's okay. Same with Elm. You can just pattern match these things. The compiler will tell you. And if you want to do the same thing in TypeScript, you just have to turn use strict on and add types to your switch statement. And so now we can map for this. So if anything breaks in upstream, we have these 4 eventualities that come out, right? And so they're just things we expect. We don't want to blow up. We just want to collect a report on it. So the step function is not always going to work or not. It's going to work, and errors would be extraneous things like an IAM role broke or you misparsed something or had a bad deployment. We want it to always work and always show success, but show a result. And that's what we're really passing on is what is the result? So in conclusion, what I really wanted to point out about AWS and Lambda applications really changed my life because I now have a single browser tab that can manage all this stuff. I can have a monorepo instead of 50 GitHub repos, but I can still independently deploy if I want to, and I can still roll back. If you want to do green, blue, you can do that. If you want to do slow canary deployments, you can do that too. And all the AWS tools support it, including those weirdos like Terraform and Ansible. From an error handling perspective, you create custom errors at a minimum to throw, but if you try to only throw it in a handler, that way you don't have to look over a whole code base. You obviously should strive for no exceptions in pattern matching, but it's a level and it's hard. So at least try with the basic try catch of customs. Watch out for high retries. It sounds cool at first, but you want to know your stuff's broken early. You don't want to wait forever. There's nothing worse than debugging for 6 hours to realize you could have solved it in 10 minutes. Timeout seconds, use it liberally. Although every Lambda and batch and EC2 has timeouts, it's good to use that. And X-ray will change your life. Set that up first, then do your performance tests. So if you've got any questions, I got a ton of links here. I'll share the presentation links so you have these links. You can learn more. Asteroid, price ranking at AsteRank is where I really got inspiration for a lot of this stuff. And the rest of this stuff will teach you about functional programming and error handling. So yeah, so thank you very much. I hope you learned, you're pumped to use step functions and lambdas. And there was no questions in the middle, so I'm assuming there's questions at the end, maybe.
All right, Jesse, thank you very much. Yeah, the questions in the middle is I'm not going to interrupt you, so I'll just let you do your
Okay.
just let you do your thing. You have a nice voice, by the way. I know it's probably maybe weird to say, but you have a really cool voice. People are saying that you're a rock star, so that's always good.
The Slavics were very explicit. They said, "Get a mic. Your mic's horrible." So I was like, "Okay, I'll get a mic."
Well, you did a great job, and I'm sitting here with my my ear thingy. Anyway, if we can understand each other, I'm looking at someone is saying I'm pumped to use Go. So normally I would say I'll also ask some questions, but I'm going to be honest. You're getting a lot of applause. People are clapping, so I have the clap emojis. I'm looking at the chat because most of the time there's a slight delay. I have 13 seconds delay. So if people are asking questions, I'm probably going to get it a bit later. So if you have questions for Jesse, ask them now. Now is the time to do that. People keep applauding, so that's also good. You're a pop star.
Who is pumped to use Go? Who is pumped to use Go?
Pumped to use Go. Let me check real quick.
That person needs a hug. Go is the worst.
He's gonna disappear.
I know a lot of people love that language.
Dominica and the last name Jakubkova is I'm pumped to use Go.
All right, we'll have a therapy session after this. It's all right. It's good to level up beyond Python, so that's good.
There you go. So last call, yeah, you're getting a lot of applause. It's always fun as a speaker to know that people are reacting to it and that they're happy what you presented. So that's good. Coming in, let me check real quick. Anyone has a question, you can also fill in the poll to let us know what you think about Jesse's presentation, about the speaker in general, and if it was useful. And like I said, I started the introduction, and you're probably gonna delete it after this speech. But I started with the programming, gaming, fitness, Jesse Borden. And if you have no clue what I'm talking about, yeah, there you go. Go check out his YouTube channel. Go check out jesseborden.com. Check in the chat real quick. No, everybody's just really excited, but they're not asking any questions. And like I said, that's okay. They can connect with you later on. So what I want to do, Jesse, I don't know what time it is where you're at right now.
It's beer time.
It's beer time. So enjoy the beer. Enjoy the rest. Yeah, some people will call it, dial in at the middle of the night. Some they start their day. So what timing you are, beer time. Enjoy the beer. Thank you for being here. And if you want to connect with Jesse, do it afterwards. We enjoyed it.
Thank you all very much.
Thank you. Bye-bye. Okay, cool. I know it's late. I know some people are maybe already having dinner. That's the beauty of OpenSlava Virtual. You can do it while you're enjoying the show. Stick with us for just another hour, and it might seem long, but we're going to do a lot of cool stuff in this hour. I've been talking about someone is saying, "Oh yeah, man, beer time here as well. Cheers, well deserved." I think it's beer time for everybody here. So take that beer, take that soda, whatever you're drinking, water, coffee, and enjoy the last speech. But in the beginning, I promised a competition, so we're also going to do a competition. And what I'm going to do normally, if I look at the OpenSlava crew in the back, it's also the question is also going to be pinned in the chat if you forget what I'm saying. But we're going to do a JetBrains competition. JetBrains, normally that rings a bell with the audience watching right now. We're going to do a JetBrains competition, and it's going to be for 10 yearly or full subscriptions for a year that we will be giving away. And the only thing you have to do, and that's the beautiful thing, so if you're now on Facebook and YouTube and like, why am I not joining in this competition? I want a yearly subscription. Go to the Hopin, openslava.sk, join the Hopin platform, and you can join in. Because it's really simple. I'm going to ask the question. We're also going to pin the question in the chat, and the only thing you have to do is give the right answer. That's mostly how it goes with quiz questions. And the first 10 people that get the question right in the chat will be contacted by the OpenSlava team, and you will win that yearly subscription. So if you want to join in, get ready. Let's see. I'm going to check real quick with my backstage team if we're ready to do the competition. Normally, I would say they're nodding yes, but I can't see them, so I'm depending a bit on my chat here. So here we go. So we're going to probably pin it in the chat. So for the yearly subscriptions, here goes the question. The first 10 that answer it right in the chat. I'm not going to name everybody, so I'm not going to do the selection, so don't wait for me to say anything. The OpenSlava team will contact you and check the chat to see if you're one of the 10 and if your answer is correct. So here it goes. The question is, under which open source license is the programming language JetBrains Kotlin? So the question is, under which open source license is the programming language JetBrains Kotlin? There's only one right answer. And if you know the answer, put it in the chat right now. The first 10 with the right answer will get that yearly subscription. So let's see. There you go. They're pinning the question in the chat. And then see who is responding. Everybody's thinking, looking up, probably Googling something here. There's some first answers coming in. I'm going to leave it to the OpenSlava team if it's correct or not. So don't look at me. You can also not bribe me. Just go for it. I'm just seeing, okay, a lot of people are jumping in. And also there, I cannot help you. So if you're just copying the answer of other people, that's a good strategy. Could also be like in school when you're looking at the other person, they're answering some stuff, but it's completely wrong. You're doing the same thing. So who knows what the right answer is? This is cool to see. Hashtag Google is not fair. Julius, you're totally right. Totally right. But there's absolutely no way that I can control. Fair, there you go. Maria is just excited. She says, I'm just going to clap. You know, who knows what the answer is? I'm just going to clap. So thank you all for joining in with the competition. I see a lot of people actually jumping in. So the first 10. Yep, there's indeed no way around. So I'm not going to connect with you on the questions, the OpenSlava team. So I'm just saying that because normally you get in the chat who's the winner, who's not the winner, who was first. I'm not going to go for that. I'm just a messenger of the question. Okay, I'm looking at my backstage here. I know everybody's at the beer. Everybody's like, okay, the next speaker, and I know you've been waiting because in the beginning people said, hey, Josh Long is coming. So Josh Long is indeed coming. I don't have him yet in my backstage, but that's okay. I'm looking at what I still have to mention. Yeah, I think there's one thing I can do here, and that's talk about everything that is going on lately. And we're mixing human with technology, and we're mixing up the speakers right now. So I think, again, today, let there be change.
Change is all around us, shaped by technology and human ingenuity. We can make it work for you and your business.
Okay, and we're back. You see how I did that there? Smooth transition into the video. I think some people are thinking like, why does he go from the competition immediately talking about the change in the world, and bam, you have your video. That's how I do it. That's the power of hosting. Now I'm checking my backstage. Like I said, everything is happening live, and this is the last one, and because which is okay. The previous speaker, Jesse, ended a bit ahead of time, and we already finished the competition. Like Maria is saying, we'll contact the winners. I don't have him yet in my backstage. That's what I'm also going to do. I mentioned what's going on, so you're not like Marnik is just keeping on talking and he wants this moment for himself. No, I don't want this moment for myself. I just want to make sure that the speaker is all tested, mic'd up, and that Josh Long is ready to rock the stage in this OpenSlava at 7 p.m. in this case, if you're in the Central Eastern time. So I checked the social media, hashtag OpenSlava. Just checking the chat. OpenSlava. So we're still very curious to see how you're sitting. Definitely if people are saying like, hey, we're having the beer, I want to see you on the internet, Instagram, Facebook, OpenSlava, hashtag, or connect with them to show how you're doing this. Are you in this virtual, what we saw yesterday, Marco Tempest room to completely extended reality, or you're just sitting there on a small screen with your drink looking at OpenSlava? And I want to know how you follow it and how you liked it. If you still want to give feedback to the speakers, go to the poll section and click on that. And then we'll get the feedback. Tomorrow, now I'm already talking about tomorrow. Still, Josh has to go. But tomorrow is Friday, and Friday is different. Friday is shorter. So I hope for the people that are already here for 2 days that they will join the 3 days. I don't know if you get a medal for it. If you do the whole 3 days, that you like get a certificate. So OpenSlava Virtual 2020, you mastered the whole 3 days. But it's going to be in the morning. So for the early birds, it's going to be at 9. So if you want to join tomorrow, don't be mistaken that it's again at 3:30, but it's going to be in the morning. We're going to start with an American lady who's going to dial in at midnight. So that would be, she's putting in the effort. She says, I'm going to get up out of bed, give you a great presentation. So it will be great if we all show up at 9. So that will be tomorrow. And we also have, like Tomasz mentioned yesterday, we're also going to have someone who worked on the Game of Thrones series. So every day, something to look forward to. Now I'm seeing in the chat that Josh Long is joining us in the chat, saying good morning. Anybody know where to go to present? Well, this is OpenSlava. I don't know if you have to be at the OpenSlava event, but if you have to speak Josh Long at the OpenSlava event, then this is the place to present. So I'm looking at the backstage team. If this really, of course, you never know in this world. Connect with Josh Long and get him the link to get him in my backstage, because it would be great if I can introduce the man that we've all been waiting for. Again, not setting the expectations too high, to get him on the road and to end the OpenSlava with a bang and get it there. So I'm checking real quick. If I look down, it's not that I'm not interested in you and the audience following. It's just that I'm checking with my team, checking with my chat. Busy times here at OpenSlava. Busy times. But I do like if it's Josh actually in the chat, which I think it is. That's a first. That's a first. So Josh, good morning to you. You're probably in there where it is morning. I'm looking forward to you. So if you can make your way to the virtual backstage, that would be amazing. I see you pop up in my screen. I announce you. You go crazy and you talk about spring, spring break, spring, a lot of spring in the introduction. Okie dokie. All right, I'm still being scared of myself. Every time I see myself in delay 13 seconds, it's like, oh, what the hell am I doing? So I'm getting instant feedback from myself. And I'm getting the news. There he is. Oh my God, he's popping up. I'm getting the news. All right, I'm still being scared of myself.
Can you hear me?
In delay 13 seconds. It's like, oh, yep, I can hear. I can hear myself in echo. But the good news is, people, I have Josh in my backstage.
Yo, can you hear me now?
I can hear you perfectly, Josh.
All right, we did it. Go team. That was awesome.
Nice. So the people, you cannot see what's happening in the backstage, but I'm currently connected with Josh. His helicopter landed. We got him as quickly to the backstage as possible. He's pumped. So welcome from the chat to my virtual room. So people, if you're watching, someone's saying, love the jokes by Marnik. Thank you very much. I was doubting to do the spring break. I was not sure about my material, but I'm glad you like it with the spring break. Okay, Josh. I'm going to announce you, give you the stage. People go wild. We'll have dancers. We'll have giraffes. Go crazy, and you can do your thing. I know you're just joining in. I know you're probably thinking, who is this weird Belgian guy who's all this pumped talking about me? It's Marnik. It's a long story, but I'm just excited. I'm just excited to get you in the show. So you're here. So here we go. So we have Josh Long. He's a Spring development advocate for VMware. He's a Java champ. He's written already 5 books. He's a Spring blogger. He's a host of the Beautiful, if I pronounce it right, podcast. Yep. And in the end, what I heard, no introduction is needed. I like the title. It's short. You're going to talk about reactive Spring. And for me, and take this as a compliment, because I like the fact what they wrote, what you're actually going to do. I see you a bit, to me, with no tech background, as the Willy Wonka of Spring, because you're saying like, if it's all difficult, if it's all a lot, don't worry, because Josh will take you by the hand, explore and guide you through your words, the wacky, wonderful world of reactive Spring together. So ladies and gentlemen, happy to have him. Josh Long, take it away. The virtual stage is yours.
Thank you. Thank you so much. Good morning, everybody. Let's see. Here we go. Share my screen. We don't have a lot of time, friends. As always, we don't have a lot of time. So I encourage you to take note of these slides right here. This is arguably the most important set of slides you're going to see in the next hour and whatever time. We have like 70 minutes. Is that true?
You're the last speaker. So indeed, you have like an hour, a bit over. So as long as the people are excited, you do your thing.
Okay, thanks. So we don't have very much time is my point. We can't stay here all night. Whoa, that I would love to. So please take note of this slide here. We have the Git coordinates. We have my online coordinates. Should you have questions, when ineluctably you do have questions, don't hesitate to reach out to me. I'm there for you. Happy to engage, happy to answer questions. And of course, the Git coordinates are pretty important. We're going to go through a lot of stuff today. The goal is not so much that you remember everything that we've ever done. It's that you remember what is possible and that you just be able to follow along at your own leisure later on, your own discretion. So please don't hesitate to do so, but not now, of course. Now, normally at a conference, I would tell people, don't do this now because you'll saturate the Wi-Fi and you might jeopardize my demo. If there is a silver lining, the one silver lining to this crazy, crazy upside down here is that, of course, you're not going to saturate my Wi-Fi. So, go for it. Have at it. It's fine. But don't worry about the code too much right now. That's what I'm trying to say. We want to keep our focus on what's ahead of us. So we're going to talk about reactive programming today. Obviously today, I was just giving a great introduction, but just briefly, my name is Josh Long. I work on the Spring team. I've done some training videos on all sorts of different topics. I have a book I wrote in 2017 called Cloud Native Java, which is all about how to build applications that survive and thrive in the cloud in terms of Spring Boot, Spring Cloud, and Cloud Foundry. I have a podcast. I have a blog every Tuesday called This Week in Spring. I have a screencast series that goes out every Wednesday, or there's something usually every Wednesday. For example, just this morning, Wednesday, about 9 hours ago. So keep in mind, it's 10 o'clock here, and I'm still finishing my first cup of coffee, but I released a video at 1 o'clock in the morning on Kotlin, right? So there's that. If you go to spring.io for such a video, you'll find a video on Kotlin, for example. And of course, I have a book that was just released, and this is in every Amazon market that you can find or on LeanPub. If you're buying the printed version, go to Amazon. If you want the digital version, go to leanpub.com. And this book is all about how to build applications that survive and thrive using reactive APIs. It's built to, it's designed to give us a way to describe reactive applications, reactive programming with Spring. Now, keep in mind, this is what we're going to talk about today. Is we're going to talk about reactive APIs. Keep in mind, reactive APIs aren't something particularly novel, right? They've been around in some form or another for, let's say 12 years, okay? What I think is interesting is this moment in time, the sort of juncture where we find ourselves right now, where now because of the use cases that present themselves when we try and build microservices, when we try and build applications destined for the cloud, we have a increasing demand for IO-centric services. And this is where we start to appreciate the benefits of building reactive applications. Because there's two things that happen when you move to services, when you move to a services-centric architecture or services-oriented architecture. The first is you have lots of input and output, right? And so while there are all sorts of different things that you could do on your computer today, anything that requires you to do input and output is potentially a candidate for parallelization or for concurrency. That is to say, when you do input and output and you're sitting on a thread, if you're just waiting for something to happen, there's an opportunity for you to be more generous with your code and to give that thread back to the runtime so that something else in the system can use it. Reactive programming gives you an API to make that trivial. So you get better resource utilization. You get better efficiency, right? It's a better bin packer. You can do more with the same hardware. The next thing that we care about when we move to microservices, when we move to services and cloud-centric architecture, is how easily can one service talk to another? How easily can they negotiate perhaps varying cadences, perhaps varying speeds of interchange, right? That becomes tricky, especially in a distributed system where you have no idea about the cadence or the capacity of another service. And so you need to negotiate that, right? This is flow control, not a controversial idea, of course. Ever since you've had one service in the same network as another, you've had to contend with that. The novelty here is that that's now surfaced as part of the top-level API. So if we understand those two high-level goals, then I think we're just about ready to start writing some software. And of course, my friends, in order to do that, we're going to go to my second favorite place on the internet. My first favorite place, obviously, is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather's amazing. It's the happiest place on earth. It's better than Disneyland. But if you have not been to production, you can begin your journey here at start.spring.io. And what we're going to do is we're going to just build a brand new application, taking advantage of all the latest and greatest. Actually, you know what? I want to encourage you, just as an aside, since we have an extra few minutes and I feel like it's worth the extra investigation, I want to encourage you just to take a look at Spring Boot 2.40 M3. Normally, for the balance of our time, we're going to spend our time looking at the GA 2.34, but 2.40 M3 is compelling for a number of reasons. And while we don't have a whole ton of time to sort of look at that, I do want you to kind of to take a look at that when you can. And I actually wrote a little project. If you go to my github.com, you'll find there's a project called webflux-actuator-graalvm. And basically, this is just a stock standard reactive application. And we're going to investigate the concepts that underpin these this application today. But what you need to understand is that there's an application. It has proxy bean methods equals false. Let me make the font much larger. I just appreciate that. Okay. It's got proxy bean methods equals false. It's got some. It's got a thing that's going to write some data to the database. So the application starts up, and there's an event, and then it uses the database client. It creates a table, saves some data to the database, finds them, and then prints them out. There's a Spring data repository, and there's an entity, and there's a REST controller, and there's another REST controller. This one's a slower one. And these endpoints all are designed to demonstrate some things that are now in Spring Boot 2.3 and Spring Boot 2.4. The first of which is that this application has graceful shutdown. So basically, when you run your software in a cloud environment like Kubernetes, it's very typical for a pod to be killed by the platform and for the platform to spin up another pod in some other place. And the only issue with this, of course, is that if you've got any existing in-flight transactions, you run the risk of having the platform interrupt those transactions. So what graceful shutdown does is it allows you to shut down the application, drain off any existing activity, and then actually shut down the application for good. That's one thing that's very nice. Another thing that you care about when you build Kubernetes applications is the concept of liveliness, which is to say the Kubernetes notion of, are you still alive? And readiness, which is the Kubernetes notion of, I've just started up, am I ready to actually start handling traffic, right? Well, now there's two actuator endpoints that are provided for you out of the box. So you can configure your pod to have a pointer to the readiness and liveliness probes. The other thing that's nice about this version is that because I've done this, right? I've done this right here, this version, this proxy bean methods, I am in a very interesting position now because I can take this application and I can compile it, right? So if you look at this code here, we don't really, all this other stuff, I'm just, setting up some color coding for the output. I'm deleting target. I'm creating an output text, I'm just creating a native image directory. I'm unpacking the jar that was built, right? I'm doing all the stuff that you need to do to build a jar, and then I'm unpacking it to I'm unpacking the jar and putting certain things in certain directories, using that to build a class path text file, or a variable rather, and then I'm passing all that into the GraalVM native image. And this is really the only part that matters here, is this native image bit. If I run this command here, assuming I have all these little environment variables there, I will get a native application, a native binary. And this is ideal in a cloud environment because now I can scale the application up quickly. It takes very little memory. It takes almost no time at all to start. And then if I wanted to, I could go a step further. I can actually have Spring Boot create a Docker image for me. Now, this is another feature that's nice in Spring Boot 2.3. I can take my Spring Boot application with no changes at all. I don't have to do anything, actually. I could just do this with 2.3. If I went to start.spring.io right now and I hit generate, this would work as well. I can actually say maven spring-boot :build image, and that would work. But the difference is that with this one, I've got this extra configuration here, and I'm telling it to use the Cloud Native Computing Foundation's Paketo project to generate a build pack to then turn my jar into a Java runtime, into a Docker container that has everything needed to run my Java application. And you can use Paketo for Python and for Ruby and for .NET and Go and everything else as well. But we just support it out of the box for our Spring Boot-based Java applications. If you use this build pack, however, and you enable this environment variable, you're going to get a native image inside the container. So imagine that. You've written your Spring Boot application, got native code, you run Maven Spring Boot build image, now you have a Docker container that contains your native application. So very, very interesting possibilities, right? And then you can publish that Docker image to any container registry. You can then kubectl apply it to, to get yourself to production. You can create a deployment and you're off to the races, right? So if I go to the target directory here, and I've already taken the time to compile this because it does take a few minutes, right? This is not a trivial process. I've got an 85 megabyte binary. This isn't a jar though. This is a machine processor architecture specific binary. And it starts up in, let's try that again. That was very slow for some reason. Oh, it's probably because I'm being recorded. Oh, that's a little bit better. Okay, there you go. 0.129 seconds, right? And this is for an application that has the actuator. It has a SQL database that I'm embedding, by the way. I'm actually starting up embedded H2 here. And it's got a web endpoint. So, if I go here, localhost, what is it, customers, I think? No, what did I call them? Reservations, there you go, right? So there's my 2 records. So you can do amazing things with the new Spring Boot 2.4. I encourage you to take a look at the Spring Growl VM project. This is not yet GA. This is the other thing that enables the native image support that we've just demonstrated. Very, very interesting opportunity. Now, that said, don't save all that. Thank you. No. Good. Okay. That said, I think I'm going to stick with the defaults. That's just saying, I want to use the GA bits. That's fine, right? So what I'm going to do is I'll go to my initializer. I'm going to build a reactive web application. I'll use Lombok. I'm going to bring in the R2DBC support. R2DBC is the abstraction for building SQL-based data access in the reactive world. And then I'm going to bring in an implementation for R2DBC. So R2DBC is to reactive as JDBC is to slow blocking synchronous APIs. Okay, and then I'll bring in Postgres. And I've just taken something. Reactive Web, R2DBC, Postgres, and we want Lombok. And we also want RSocket. Okay, so we're going to call this service. And I might bring in Spring Security just in case. We might comment it out. I don't know if we'll have enough time, but you never know. We could, right? The other thing that we have here are the choices of Java. Now, of course, my friends, we have before us 3 checkboxes, but really only 2 choices. And I want us to just sort of reflect on that. Let's stew in the contradiction, the paradox of having 3 checkboxes, but just 2 choices. You see, friends, it's late 2020, and in 2020, there's no reason ever to be using Java 8. Java 8 is long behind us. It's way in the rearview mirror. We shouldn't be using that in production. Trust me, you don't want to do that. There's no reason. It's technically and morally inferior. It's technically inferior in every way. It's slower, it's less feature-rich, it's less secure, less robust, etc., less performant. I mean, it's just not a good idea technically, but it's also morally inferior, friends. It's a morally bad choice. Do you want to have that conversation with your children? Well, you have to tell them you're still running an ancient, creakingly old version of Java in production? I don't think you do. I don't think you do. You're not gonna enjoy the look of despair on their tiny little faces when you admit to that. Okay? Don't do it. Use Java 11 or later. Java 11 is the current long-term supported version of Java. It's awesome. Lots of great stuff in there. You can also use Java 15. Java 15 is a current supported version of Java. Now, granted, it's got a 6-month release cycle, so you'll be obligated in 4 months if you want to avoid having to pay support fees to move to Java 16. But this isn't really a problem, friends. This is not a problem of actual concern. It's nobody's holding your arm behind your back and saying you must use the faster, more secure, more stable, nicer version that's completely backwards compatible. I'm just saying it's a privilege. We get to use these nice new versions of Java, and we don't have to worry all that much about how that works. So let me just make sure that I am using that right now. So I have a bunch of Javas on my local machine. I use something called SDK Manager. And SDK Manager makes it trivial to switch from one version of Java to the other. So let me just make sure that I've chosen this for the moment instead of Growl as my default. I'm going to use 15.0. All right, good stuff. And I'll make it default as well. Actually, is it default? Let's just see what Java says if I go here. It is the default. Never mind. Oh, that was for not, friends. Okay, so we're going to hit generate. That'll give me a zip file. And we'll open that up here. Okay, making the font as big as I can. Alrighty. C downloads UAO service.zip. Oh yeah. Okay. Oh, you know the biggest pity is I can't zoom in anymore. You know, it occurs to me, friends, you might not be able to see this. Let me just make this a little smaller. Okay, hopefully you can all see that better. Okay, so we have a new application. And this application is just a stock standard public static void main Spring Boot application. Nothing all too fancy about that. I'm going to make my font a little, I just really want people to see this. There we go. So it's a public static void main application, nothing all too fancy. We're going to use hopefully everything in the build, but we don't know. We might not. So let's comment out some of the dependencies that we don't need just yet, including but not limited to Spring Boot Starter Security and the corresponding security implementations for our socket. So there's that. Okay. Goodie. Okay. So there's our build. I've commented out our socket and the Spring Security. Well, no, I've left our socket, but I'm not going to use it, right? We don't need this as well. So there we go. There's my revised build file. I'm going to hit reload. And with that, I now can write code without concern that I'm going to inadvertently start up something I don't need. Now, again, we're using Java 15. Java 15 is awesome. So there's a lot of really compelling features. For example, var message equals hello world. See, look at that, multi-line strings. It only took 25 years, but they're here. And we've also got var, right? Auto variable type inference. So var, whatever, var x equals arrays.asList, right? Lots of nice features here that I encourage you to check out. But for our purposes, it's just a really nice runtime. So what we're going to do is we're going to build an application that writes data to the database. And we're going to start, as usual, with just our domain model. So we're going to write to a SQL data store. In order to write to a SQL data store, we need to specify a connection string. So we're going to use an abstraction called R2DBC. Now, R2DBC is a reactive relational connectivity abstraction, right? Reactive relational database connectivity abstraction. And when you connect, it looks kind of like Postgres. It looks like JDBC, right? And so if you go here, username, orders, and then password is equal to orders, and voila, there's my connection string. Nothing all too fancy there, right? Now, once I've got that, I want to describe a Java object that maps to a single row in the database. So I'll create an entity, if you will, here. It's an entity with a single field for an ID and another one here for a name. And that's the essence of what I'm trying to express. But of course, I can also use I want to synthesize getters, setters, toString equals, hash code, etc. So I'll use the annotations here to get that done. And then finally, I want to create a repository. I'm going to create a repository like so, extends reactive CRUD repository. And this is just an object that's going to manage the tedious, soul-annihilatingly boring read, write, update, and delete lifecycle of my data. Now, this done, I can now write some sample data to the database. So I'm going to create a sample data initializer, right? So this is just going to be a Spring Bean that listens for an application context event and writes to the database when the application is ready, okay? Now, this is just a callback. It's just an event. And in this event, in this callback, I'm going to need, of course, my repository. So I'll inject my reservation repository. And I want to inject it into the constructor. So I can tell Lombok to synthesize that constructor for me using the required args constructor. And that done, I can create some names. And so what I'm going to do is I'm going to create a reactive stream of names. I'm going to use this type called Flux. We're going to talk about Flux and Mono and all these things in a minute. But let's just create the stream of names, okay? So we're going to list people on the Spring team. There's, of course, Stefan, right? there's, of course, Madura. There's Violetta and Olga. And who else do we have? Spencer. I'm on the Spring team. I count, I guess, so I could add myself there. Who else do we have? Yushin. There we go. And I'm sure there you go. Right there we go. So there's a few people that are in the Spring team. Ria as well. So there's some names. Now these are names. These are things that I want to turn into actual records in a database. So I'm going to visit this reactive stream of names, which kind of looks like a Java collection or a Java 8 stream. I'm going to say names.map, and I'll map each new name into a reservation. And that gives me a reactive stream of reservations. And then I'm going to map each one of those and write it to the database. But the thing is, if I do just map, if I just do this, .save, what happens? Well, if I call .save, save returns a mono. Can you see that? A mono of reservation. And so the behavior of map is to accumulate the output of my Lambda into a container type. In this case, it'll be a publisher, a flux, right? So if I do that, I'll get a flux of mono of reservation. Nobody wants a flux of mono of reservation. That's entirely too many reactive stream types. So what I want to do is I want to unpack that intermediate type here. Okay. There we go. So there's my rewritten thing. But in order for that to work, I need to change the operator that I'm using here. I'll use flatmap, right? Flatmap helps me flatten these two asynchronous streams. I've got reactive types inside of reactive types. I want to flatten it one level down. I want to smoosh down the asynchronicity, basically. I want to just take the outermost layer of reactive streams and flatten the innermost ones. Just like the curve, we want to flatten our streams, right? Very important. So that done, I can turn this into a Lambda. And that's basically the entire pipeline. I've described a pipeline that has names that are going to get turned into reservations that are going to be saved in the database. But if I ran the code as is right now, you would find that nothing's actually happened. I need to actually trigger the pipeline. And then you do that by subscribing. You say subscribe. So, and then here's the output, and you can print it out, and then voila, okay? There's the entire stream. That's the result, etc. Now, when I subscribe, I'm actually triggering the pipeline. I'm turning on the faucet, if you will. I've connected the pipes in the pipeline, but now I'm turning on the faucet. Subscribe is very important. Otherwise, this pipeline is just inert. Nothing happens. Nothing will be reflected going over the wire. There will be no bytes conducted from my local machine to the database, etc. It's just a pipeline. It's just Java code that has strings and variables and all that stuff. Nothing happens. And so it's very important that you subscribe. But there's no reason you couldn't have defined this today and then left the Java program running and then run this pipeline tomorrow. You can hit subscribe tomorrow. So there's a difference between execution time and assembly time, right? Assembly time is when you create the pipeline. Execution time is when you actually run the pipeline. And there's a delay there. There's a gap. There's a bit of disconnect. And that means that you can do things in between when you first start defining the pipeline and when you actually execute it. Or rather, more importantly, the framework can do things for you. So we've been building this pipeline, and what I wanted to show you is how easy it is to do this, to use this API. In fact, if you kind of just turn it all into Java 11 auto type inferred variables like this, right? You don't even know it's not Java 8 streams, right? And in fact, if you go a bit further and you string these things together, it's hard to tell it's not even JavaScript, right? This is actually a very, very concise representation of my code. So what have we actually done? Well, we're using this type called Flux. Even though it looks like a Java stream, it's not. It's a reactive type, and it comes from a project called Reactor. Reactor is the library that underpins our efforts in the Spring ecosystem to support reactive data flow and composition. Reactor builds on top of a library called the Reactive Stream Specification, which provides 4 very simple types. And you can see these types here. Here, right? Publisher comes from reactive streams. So org reactive streams publisher will publish data asynchronously out of band at a separate time to a consumer. That consumer is a subscriber. the subscriber gets each new record in the onNext method. When there are errors, if there are errors, they are delivered on the onError method. When the subscriber has reached the end of the data that it gets to process, the onComplete method will be called back. And these are the three basic lifecycle methods that you're going to deal with for most of the lifetime of your application. What you will deal with at the very beginning of your subscriber, at the very beginning of the lifetime of that subscriber, is this thing called a subscription. And this is arguably one of the most important types, which is why we talk about it now. A subscription represents the link between the producer and the consumer being the subscriber, the producer being the publisher. It is the thing that the subscriber can use to either request more data of the publisher or to cancel the processing of the data altogether. Very, very important here, right? If I, as a consumer, am getting overwhelmed, the worst thing that you as a producer can do is just to keep handing me things to do, right? So I want to be able to push back. I want to be able to say, no, I can't handle anymore. Please, no more, right? And so that's what's happening here. I can request 10 records, and then I won't get anything more until I request another 10 or 1,000 or whatever records. You can request as much as you want, but only so long as you're sure that you can handle as much as you've requested. So if somebody gives you, 5 billion tasks to do, you're going to be very overwhelmed. You'd much rather have one at a time, right? Same thing for a computer. Give the subscriber just as much as it can handle in one fell swoop without being overwhelmed. If I just am no longer interested in doing the work at all, if I just want to say, okay, never mind, I've just abandoned this work altogether, then I can cancel. This is flow control. We talked about this earlier. This is one of the things that you care about when you're trying to establish more robust services. You might also hear it inadvertently or sometimes interchangeably referred to as back pressure, right? It's the same thing. It's this idea that I'm going to push back on the producer so as to ensure that I, the consumer, am not overwhelmed. Very important. And all we've done is we've just surfaced these types as part of the Java API, right? Again, flow control is something you've had to deal with ever since one computer talked on the same network as another. Not a big deal, right? Not a big deal, not a big thing. It's just nice to have it as part of the API. Now, I say that there are 4 types in the reactive stream specification. The fourth one is called processor. A processor is a bridge. It's a source and a sink, a producer and a consumer, a publisher and a subscriber. And that's it. That's the 4 types. If you understand those types, congratulations. You're certified reactive. Go to Silicon Valley, raise $1 billion and throw it all and waste it all on stupid parties. You're ready, right? You're ready to be part of the Silicon Valley scene. That said, I think we can agree these reactive stream types kind of boring, kind of basic, right? They're very trivial. And so we have 2 types coming from Reactor. One of them you've already seen, that's Flux, right? A Flux is a publisher. It ultimately implements publisher, but it has a lot of code in it. And this code supports operators, things like map and flat map and filter and, on back pressure and error and composition and sorting and all this kind of stuff. Look at all this code, just so much code, stuff I don't want to write. 2,270 lines of code. We've also got a mono. So a mono is yet another publisher, but it produces at most 1 value, and it can produce 0 to 1 value, whereas a Flux can produce 0 to n, where n is potentially unbounded. So we've got these reactive stream types. We've got our data in the database. Let's now actually consider what we want to do. Well, I have actual data in the database. One of the things that you can do is you can create a service, right? You can actually have a service that does transactional work. And that service could be pretty trivial, right? Class reservation repository, reservation service. And the service is going to depend on my repository. So I'll say reservation repository. And the service is just going to write data to the database, but it's going to do so in a more coarse-grained way. It's going to have a business method that'll take a bunch of names and return all of the objects that it's been given, right? So save all string names. And what I'm going to do is I'm going to say return this.reservation repository at save all. Or better yet, I can take that logic that we just created earlier. We'll say flux.just from array names. I'm going to take each one of those and turn it into a new reservation, like so. And then we're going to save it. We're going to say flat map r this.reservation repository at save. Now, suppose I wanted to also do some validation, right? I want to make sure that when the application completes writing all the data to the database, that we also validate what we've just done. And so I want to now, on each write, I want to also validate the data. So I'm going to say, run this assertion about each record. I'll say, each record must start with a capital letter. So get name car at 0 is got to be a capital letter. So character is uppercase, right? There we go. Very simple. The name must have a capital letter. Okay. Now, very simple logic, right? Not a big deal. You can see what's happening here. I want to make sure that either all of this data gets written correctly or none of it. So of course, I can use add transactional here, right? Spring has this annotation called transactional. You can also use the transactional operator, in which case you can wrap a lambda inside of a transaction. But the important thing here is to consider what we're doing. Remember, reactive types move work from one thread to another. There's no guarantee that this line here will execute on the same thread as this, and that will execute on the same thread as that. Threads can change underneath you all the time in reactive API. And it doesn't matter because we're not writing threaded code, we're writing reactive code, and so we still get much more safe, much more deterministic behavior if we stick to these operators. That said, it does introduce some risk. It does introduce some concerns that you might have. For example, how do I use transactions which have historically been based on thread locals if I can't be sure of the thread on which this reactive pipeline is going to execute? Well, behind the scenes, we're taking advantage of something called a context, okay? And so you can do this as well, right? We have this thing called a context, and the context is just a key value thing, right? Blah, 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 context, okay? You can change it, you can use that as well, but the benefit for us is that this context is a way to propagate data along the life of the reactive stream. We use it to make sure that we stash the current state associated with the current ongoing transaction. So you don't have to worry about it. Add transactional works just as you expect it would, right? Even though it's not using thread locals anymore. It's changed to support reactive APIs. Okay, very convenient. Now we have the service. Okay, the next thing I want. What is the next thing I want? Well, I've written all this data to the database. Let's use our service. First of all, reservation service. Okay, reservation repository. Good. And what I'm going to do is I'm going to take all these names. Here we go. We'll say this.service.saveAll. And then we're going to take all that data. We've already written the data to the database. I'm going to see the transaction in action. But before I do that, I want to clean up the state of my database first. So I'm going to say this.repository.delete all, right? And then once that's all deleted, then and only then I want to process the names. I want to say write the data to the database. And then and only then I want to say repository.findAll, right? And then finally I'll subscribe, okay? And here I'm going to print out the results as they arrive. So again, I'm running asynchronous code. I'm running deterministic concurrent code, right? But I don't have to worry about that. But I did create one section that's enveloped in a transaction. So let's say I lowercase my name, okay? That should, if we understand everything, everything's going to be deleted. And then either all of these 8 records or none of them will be written. And then when we do find all, we'll get all the results, but there should be nothing left because we have a bad record. So let's see what happens. Let's run this code. Connection refused. Did I inadvertently list? Oh, hey, brew services start. Okay. Good. So PSQL U orders. Not MySQL, select all from reservation. Good, we've got that data. Let's delete it. Actually, it'll get deleted anyway, but delete from reservation. Okay. Run this again. Okay, there's our data. Now what? the name must have a capital letter. See that? So our logic is kicked in, our validation logic is kicked in. So it's working as we'd expect, right? That's good. Now, if we go to our database, nothing is there, right? So it didn't write a single name. It didn't write 1, didn't write 3, it didn't write any of them because there's a transaction. That said, if I go back and fix the name, we should see all these records written to the database. Port 8080, what is on port 8080? Oh, this thing, of course. Okay, there's our data, there's our 8 rows, there they are on the console, everything's working fine. So transactions work, SQL-based data access works, HTTP, we don't have an HTTP endpoint. Let's build an HTTP endpoint. So that's easy enough. We could use @REST controller. We could say class reservation REST controller, no problem, right? And we can inject the reservation repository there. And that's fine as well. And then we can create an endpoint here, reservations, and publisher of reservation, get that. Let me say return, this type reservation repository, find all. And there's my endpoint, right? That works just fine. That's something that might look familiar if you've ever used Spring MVC. Keep in mind, though, this is not Spring MVC. This is Spring Web Flux. It's a brand new reactive web first runtime. This API is familiar. I like it, but I have also really quite grown to like the functional reactive style. And the way this works is you create a router function, server response routes. Okay, build .get /reservations new handler function, and I'm going to return a server response .ok.body. And in order to satisfy this dependency, I'm going to need to inject my collaborating object there. Voila, there's my entire API. Now I can clean this up a lot. I can get rid of the static I can add static imports rather, etc. And now my whole HTTP endpoint becomes this one-liner, and it's a fluid builder DSL, so I can actually add other endpoints here without complicating the code. I don't have to declare whole new classes, etc. So it's very nice, and it's a choice. You don't have to do one or the other. You can mix and match. You can do both. Okay, so now if I run this, I've got a reactive application that starts a web server that starts listening for data requests on port 880 that writes to a SQL database, and I can hear you all saying, so what? Who cares, right? Like, I could have done this yesterday, Josh. I don't need reactive APIs to write 8 records to a Postgres database in 2020. We could have done this using servlets and JDBC just fine yesterday. And to that I say, you're right, absolutely, that's true. But what I'm not really trying to persuade you just yet of the superiority of reactive programming. What I'm trying to convince you of is that for the most part, working with reactive APIs is not any more difficult than it was before, and you can do all the things that you would have done before. We've just created a stock standard trivial reactive application that talks to a SQL data store that has an HTTP endpoint that does JSON and does transactions. Cool, right? Nothing has changed. The code is trivial. Actually, there's less code here than I bet you would have written for a lot of things, right? Consider that this is just a demo. This is not going to be in your production code. So really, that's it, right? There's my entity, my repository, my service, and my HTTP endpoint, right? So, not a big deal. Something's going on down. I'm 12 floors up in San Francisco, and yet sometimes you can hear road noise. Weird. Okay, so we have all of this. We have our pipeline set up. Well, I've demonstrated to you that you've got parity. You've got the ability to do what you could do before. Let's talk about some use cases where you really benefit, okay? So first things first, I want to build a never-ending service. I'm going to build a service that emits data in a kind of constant fashion. So I'm going to create a greeting service. And this greeting service is going to provide a reactive stream of greeting response given a greeting request. Okay. And we're going to use the request with a name to produce the response, like so. And the response will have a message. Now, I'm going to use Lombok, of course, to synthesize the getters, the setters, the toString, etc. and make short work of all that busy logic. And what I want to do here is I want to just create a simple bean that's going to return an infinite stream. So return flux.stream.generate. Okay, new supplier. And this is just going to return a new response, new greetings response. Hello, request.getName at instant. Instant.now. Goody. Okay. And of course, I want to delay elements. So I've got this reactive stream. And I want to delay the data as well. First of all, I want to limit how much I take. I want to take just, let's say, 100 records. And then second of all, I want to delay the elements. I want to limit the speed. I'm going to slow it down artificially so that we can synthesize something that's long running, something that'll take time in the future. So I've got a service, and now I want to create an endpoint to make this data available over the internet. And I've already used HTTP to create my reservations endpoint. I could, I suppose, use HTTP here. I could try and do something with server-side events. That might work. But of course, it has all the limitations of HTTP, which is to say it only understands request response, and it's textual, and it's very inefficient as a payload and so on. I could use WebSockets. WebSockets don't have headers, though. That's a little awkward, right? How are you supposed to do on-the-wire, out-of-band information like a token, right, for security? So what I want is something that is operations friendly. That is to say that it has information about the state or the health of the service for my service. I want something that is reactive. That is to say it understands true back pressure, right? With HTTP, I can only cancel, right? Have you thought about that API earlier as we've been looking at these protocols? If I have a HTTP client that connects to my reactive HTTP service and the client disconnects, what's the best that I can do? Well, I can actually perceive that disconnect and cancel. That's it. There's no way for the client to request 10 records and then request another 10 an hour from now, right? This is the problem. So that's not going to be great. So all I can do is I can cancel. That's one-time back pressure. I want true session resumption and cancellation, right? And so I can get that, and I can get operations, I can get reactivity, I can get different message exchange patterns beyond request response, I can get headers, I can get binary payloads, I can get all sorts of good stuff by using a protocol called RSocket. Now, RSocket was developed, it was forged in the fires of production at Netflix and Facebook by engineers there. And the result is something that is really compelling, right? It's a very, very interesting protocol. It's being used at scale by Facebook, Alibaba, and a number of other organizations. And the Spring team, along with Facebook and Netify and so on, are the sort of main contributors to this technology. It's now part of the Reactive Foundation, which we co-founded as well. So this protocol, very interesting. There's a lot of different clients for it. There's different implementations for the different languages, including Java, C++, and Go, and JavaScript. Well, of course, the Java implementation uses Project Reactor. So it was trivial for us to integrate it into Spring. And so that's what we've done. I'm going to build here a regular Spring controller based on RSocket, right? So RSocket controller. And I'm going to use my greetings service. We'll inject that here as always at message mapping, greetings, publisher, publisher, greetings response. Okay, and we get a greetings request. Return this.greetingservice.greet request. There we go. That's the entirety of the code that I need to write to be able to create an RSocket endpoint. It doesn't have URIs so much as destinations, okay, or and you can see we've got that. There's even destination variables, right? So I can say ID, for example, that kind of thing if I wanted to, in which case I would say destination variable string ID or integer, right? I could do that. And, you know, it works very similar to Spring MVC controller handler mappings, and it has a lot of the same benefits of it, right? So I've got an endpoint. In order for this to create an actual RSocket service, I need to tell my API to set up an RSocket port. So I'm going to say RSocket server port equals 8888. Now with that done, I can talk to my RSocket service a couple of ways. I can use the RSC command line. RSC is a kind of like curl for RSocket endpoint. So I can say that I want to call TCP localhost 8888. I need to tell it what kind of interaction I'm doing. So in RSocket, you have 4 types of interactions. You have request response, where you have a single value that comes in and a single value that goes back out. You have request stream, where you send a single value in and get a stream of values back, which is what we're doing, by the way. So -- stream. You have multiple values in and multiple values out. That's called channel. And you have fire and forget. So you can send a single value in and then ignore the response. And this is a very common thing in messaging, right? We care sometimes about the acknowledgement of the request, but sometimes we don't. Sometimes it's just, if you got it, great. If not, that's okay. There's more coming, right? So for example, metrics or telemetry or logs or, heartbeat events. If you miss one, who cares? It's not the end of the world. Frames in a video, right? There's most protocols, most of the services that need these kinds of things have error correction built into it, right? And so we may not need all that. Fire and forget is very useful, but it's just not easy to do with HTTP. It's very natural to do it with something like Kafka or RabbitMQ or ActiveMQ or whatever. Okay, so stream. The endpoint, the route is called greetings. And the data that I'm going to send in, we can use serialization here and content negotiation. I'm going to say the name is equal to OpenSlava, okay? And when I do that, I get back a stream of responses. So there you go. There's my data coming back. And remember, this is binary data, but since I sent in a JSON payload, it's converting it back for representation on the console into JSON, okay? So that's one way to communicate with your service. Now, of course, what I want to do is I want to build a client. So we'll go here and we'll build a client. We're going to use the reactive web support. We're going to use Lombok. We're going to use Spring Security. And I need RSocket as well, right? So we're going to build a client. We're going to hit generate. UAO client.zip. And this client will just act as a client to our remote service. So I'm going to build a new reactive application. The endpoint, well, the first thing I'm going to do, I'm going to connect to my HTTP endpoint. So I'll say I want to build a reactive endpoint. This will be my HTTP client, okay? And I'm going to build a bean, application listener, application ready event, ready, and whatnot, okay? Now, what I'm going to do is I'm going to inject here my reactive non-blocking HTTP client to make calls to that downstream HTTP service. Now you remember, the service is just reservation. So I say localhost 8080 / reservations. I'm going to take the data that comes back. I'm going to turn it into a stream of reservations. So I'm going to turn the Java data into these Java objects, the JSON data into these Java objects. So I'm going to do something terrible, something that you should never ever do ever, not even when you're all by yourself at home and no one is looking. I am going to copy and paste code. So that's not great, right? Don't do that if you can avoid it. And I'm also going to take my reservation down here. Okay. Good stuff. Okay. Now we're going to take the data that comes back and we're going to turn it into a reservation. And I'm going to just log it out. I'll log out the results. So system out print line. Okay. All right. So there's my reactive non-blocking client call on the wire. But consider what I'm doing here. I'm making a network call. I'm getting back a reactive stream of reservations, right? And then I'm subscribing to the results. What if something goes wrong in the service? Well, this is where Reactor and reactive programming gives us a leg up. It gives us an advantage, okay? I can actually say, oh, well, if something goes wrong, I want to retry, okay? I want to retry when, and I want to do a back off, right? I want to try it 10 times and then wait 1 second longer for each back off, right? So that's retry. I can actually tell it to automatically retry the request. Very trivial. What if something still goes wrong? Well, I can say, oh, well, if there's an error, then I can tell it to look for, let's say, this error. And when that happens, I can decide what gets returned. So here I just return an empty stream maybe, right? If there's a particular exception that I'm looking for. Otherwise, just do this, right? In which case I'll get to control that. Okay, what if I still have an error and I want to make sure it doesn't hang, right? Well, I can use a timeout. And timeouts are a pretty natural way of saying, hey, this is upper bounded. This is never going to take longer than 10 seconds or whatever. Obviously 10 seconds in the era of microservices, in the era of cloud computing, is an eternity. You don't want to wait that long. But we have 10 seconds. So why would you use timeouts? What's the goal? Most people who use timeouts are doing so that they have a chance to try again, right? They want to upper bound. They want to avoid losing the opportunity to produce a response for their client. So let's say that I've limited the time that I'm going to spend calling this service to just 10 seconds. Well, 10 seconds, again, an eternity, but to 10 seconds, okay? Now, what that means is that after 10 seconds, this will be done. Whether it's going to be successful or a failure, it'll be done. If it's a failure, I want to try again, right? That's the whole point of a timeout. I want to make sure I don't waste my opportunity to get a response back. So that must mean that I must have a 20-second SLA on the service here. On this client actually has a 20-second SLA, right? Because that means if I fail once and it finishes in 10 seconds, I can try again, okay? Well, what about this service? What about the reservation service? We just wrote it, so we know what it's doing. But let's suppose that instead of just doing what it's doing, it's actually calling another service. Okay, so this one, the client calls the service, and then that service calls another service. Well, remember, this service, the reservation service, has to respond within 10 seconds. So if it's trying to meet its SLA, that means that when it calls another service, it can only take 5 seconds, right? Because it wants to finish that and then try one more time. This is the problem. Imagine that service downstream now needs to call yet another service. So 2.5 seconds. You see the problem? It's decaying very quickly and we're running out of time. So this is not a good pattern, right? It's not a good pattern to use timeouts. You should have them, but they should not be your first line of defense. A much better pattern to guarantee that you get a response is to use something called hedging. Hedging. Now, in English, we say we want to hedge our bets. You've heard the common aphorism, don't put all of your eggs in one basket, right? Don't invest everything in one option in the market, for example. If you invest in stocks, you should never buy just one stock. Put all of your money in one stock. Don't do that, right? Dangerous, because if that one stock goes down, then you've lost everything, right? So you want to diversify the risk. You want to spread the risk across multiple options. And the same is true here. Let's suppose that I rewrote this to have different hosts, right? And import, okay? And let's suppose that this is parameterized, like so. Okay. And let's move that onto a variable, a method rather. Refactor, extract method. Okay. There you go. So now I can parameterize the host and port. So the host is host 1. And the port is 8080, okay? So, okay, I'm calling host 1. What if that host is down? Well, I can always, to make sure that I get something back in time, I can always ask my service registry. I can go to my service registry and I can say, hey, service registry, how many services do I have out there? And you can use Kubernetes, right? Kubernetes has its own service registry built in. You can ask it for all the services that match a given label, for example. So I can say, okay, host 2, give me host 1, and give me the results from host 2. So I'm calling 2 services at the same time, or maybe better yet, 3 services at the same time, okay? Remember, I haven't launched any of these yet. I haven't subscribed to any of them. I've just got 3 of them. What I want to do now is I want to say, okay, all 3 of you at the same time, go out, give me the data, and whichever one returns the most expeditiously, the most efficiently, the quickest, then I want to keep that one and I want to throw away the other 2, okay? Well, this is hard code to write. Can you imagine how you would write this, right? You're going to launch 3 threads at the same time. You need to somehow do a countdown latch, right, to make sure one of them, whichever one returns, you get that one. And then you need to cancel the other 2 when they're in flight. That's going to be weird, right? It's not going to be easy. In reactive APIs, it's very easy, right? So you say flux.first, host 1, host 2, host 3. And again, not a particularly hard thing to do. So now that's the result that I want to send back. That's whichever one I get back here, whichever stream I get back is the fastest one. It's kind of like in POSIX, you have the select function, right? Right. The select function gives you the ability to say, given a bunch of file descriptors, return when the first one emits a byte, okay? So very, very useful pattern. And the result is, yes, you're making 3 calls. So yes, there might be some redundant network traffic. And of course, you shouldn't use this for endpoints that are not idempotent, right? Idempotent means that you can invoke them without any undue side effects, undue observable side effects. Change to what? Idempotent. Thank you. You should be able to invoke them without any undue observable side effects. That is to say, do not use this for the charge the customer credit card endpoint, of course, right? But very useful pattern. And now I'm guaranteed one of them will return. Maybe the first one's down, right? Maybe it's garbage collecting. Maybe it's slow. It doesn't matter. You need a result. So you call the second one, and you call the third one all at the same time. Whichever one is fastest, you get the response. Again, very easy to express this using reactive APIs. You can see, I don't care about that. You can see we've also got all these operators to make our streams more robust, more efficient, more resilient, okay? So I like these APIs. There's a lot of interesting things that you can do here though, right? You can also do very easy scatter, gather, service orchestration composition. So for now, let's suppose that you have 2 types, okay? You have an order, and the order, let's say that the order has a customer ID. So you have 1-to-many orders for each customer. And then you have class customer, string ID, and string name. Okay, good stuff. Look at that. So you've got customers and orders. And now let's say that I've got 2 different services that I want to make a call to, I want to connect to. Well, so now I've got a stream of customers. Okay. To do. I'll leave it to your imagination how we get that. Just make a network call, right, with WebFlex, with the web client there. And I also have I want to say for each customer, give me all the orders, right? So let's go down here, paste that here, and what's the unhappy issue? Okay, there we go. Yeah. So I've got now, let's say that I've got a client, and then we're just going to create the interface so that we know what we're dealing with here. And the client will give me get all customers, okay? And for each customer, I want to get all the orders. Get customer orders, string customer ID. So now I've got this client, and I want to make a call, get all the customers, and then for all the customers, get all the orders, right? This is an n+1 problem. You can see it's going to be problematic. But at least when we make this call, we can use concurrency. So yeah, we're launching multiple threads at the same time, but we're doing it as efficiently as possible, right? So now what I want to do is I want to say, okay, for each customer, I want to, first of all, I want to get the customer and the orders in the same place, right? My goal here is to create an aggregate type, a new aggregation called customer orders. And again, I'm making calls to, imagine that these are calls to 2 different microservices, right? The orders and the customers endpoint. So it'll be list of orders, and it'll be customer, okay? Good stuff. Very, very simple aggregation. Now I'm going to take each one of these customers, and I'm going to build a reactive stream out of it. I'm going to build a tuple out of it. So I'm going to say flex.zip. And my goal is to take 2 reactive streams and pair them together. So that's what the zip operator does. It takes two streams, takes one from one side, one from the other side, and then creates a new thing called a tuple. So I need to give it 2 streams. So the first stream will just be the customer, right? Mono.just customer. And the second one will be the client. We're going to use our CRM client that we created earlier. That's, we're just imagining it right now. We're going to use the CRM client. We'll say CRM client dot get customer orders for customer.id, right? Okay, so when I make this call, what do I get? I get back a very confusing publisher of publisher. So so first of all, that's flat map, isn't it? I get rid of this and that, okay? And I have a flat map of tuple of customer of order. I don't want individual orders. I want all of the orders. So I'm going to say collect that as a list. And that gives me back a different type, doesn't it? So if I go here, I get a list of orders, right? So now I've got a reactive stream of a tuple, which has a customer and a list of orders. That's basically it. All I got to do now is turn that into my customer orders, right? I map tuple into new customer orders. So a tuple, and I need to create a constructor here. Required all our constructor. Okay. There's this, and so I pass in tuple.get T1, that's the customer. Tuple.get T2, it's the list. And if I look at that, I've got now my stream of customer orders. And again, we know that these streams, these calls, could come from my CRM client, which could be backed by the reactive web client. I can be making network calls to many different services, but because I'm using reactive APIs, there's no problem, right? And it's concurrent, right? I'm doing this at the same time. Great for composition, service orchestration composition. So we can see with reactive APIs, it's easier to compose services and it's easier to build more resilient, robust calls to the network. Now, okay, all of that, just conjecture. Obviously, none of that's going to execute because we have null everywhere. Let's get back to what will execute, right? So we will say get reservation flux, HTTP, localhost 8080. And we're just going to subscribe. That'll be our, R, okay? There's our HTTP endpoint. We also want to talk to the RSocket endpoint. So I'll create an RSocket requester, .builder. Okay, and now in the RSocket world, there's no such thing as client server, right? You have requester responder. And so either side, once connected, can talk to either side and they can do whatever they want to do. And so you build a client and you build it once when the application has started up, and you can inject that and use it for the rest of the application. And you don't have to specify over and over the host and port, right? So here, I'm going to say rsocket.route greetings. And the data that I'm going to send in is the greetings request, OpenSlava. And the data I'm expecting back is a greetings response. And I'm going to subscribe. System out println. Now notice what we're doing there. We're using these reactive APIs, and because they're all reactive APIs, it's super easy for me to glue them together, to compose them. Right? If you think about all the things we've done today, we've looked at transaction, we didn't look at WebSockets, but we could have. We looked at REST, we looked at RSocket, we looked at all sorts of different ways of creating streams of data, and they're all just reactive streams. I did it in memory in the very beginning. They're just reactive streams, right? Oh, port 8080 is already taken. And because they're reactive streams, it's actually easier for me to glue these things together to make them talk to each other. And this is, I think, one of the most amazing parts about reactive APIs. It makes your code easier. You don't have to learn different APIs for messaging, for Kafka, for RabbitMQ, for Kestrel, for all that stuff. You still use Kafka. You still use identify something. No, there. Just you can still use these reactive APIs. You can still use all these same APIs just like before, but now they compose together. I can merge them. I can filter them. I can make calls, distributed calls, and do scatter gather operations against them. And it's easy because it's one kind of stuff. Are you using Kafka? You're using a publisher. Are you using RabbitMQ? You're using a publisher. Using HTTP? You're using a publisher. Using RSocket? You're using a publisher. Do you see my point? So now, with reactive programming, hopefully, my friends, you see that there are some interesting possibilities. We looked at how you can do what you've already done with existing APIs and familiar technologies like HTTP and SQL. Of course, there's also rich support for NoSQL data stores. I didn't even show you any of those. We could have looked at, well, besides all the SQL data store implementations, we could have looked at Google Cloud Spanner and MongoDB and Redis and Azure Cosmos DB and Cassandra and Mongo and Neo4j and Couchbase and all these other ones that support reactive APIs. We looked at basic HTTP. We could have looked at WebSockets as well. We looked at RSocket. We saw that you get to do basic things that you were doing before, but you also have some new opportunities like RSocket, which is natively reactive. There's no way to use RSocket without reactive APIs. I hope now you've got a sense for some of the possibilities here. Hopefully you've seen that you can do everything you could have done before. You get better, more resource-efficient code. You're actually doing more with the same hardware. You can handle many more transactions with the same computers. You're not wasting RAM or CPU capacity. You get more predictable code because remember, there's only one person who truly knows how to write multi-threaded Java code, and it's not you. That's the important part. I don't know who it is. Nobody does, but it's not you, my friends. That's the important thing to remember. Threads, there's no safe way to write them, right? I saw a great quote yesterday. It made me laugh. I tweeted about it. It was basically, it was from the evolution of Lua, the programming language, and one of the authors said that it is our thinking, our holding, that it is not safe to write programs in a language where A equals A plus 1 is not deterministic, right? Basically, if something as simple as incrementing a variable can fail because of threads, then you're dealing with a landmine, right? So with reactive APIs, you greatly remove the source of those errors, right? And also, you get ease of composition. So you have less code to write, less APIs to learn. You get more flexibility, more robustness, and so on. The other thing that we didn't get to look at, my friends, is the opportunity for using this with Kotlin. Kotlin is a programming language that has taken the world by storm. It's the second most productive, most prolific language on the JVM. And Kotlin gives you the ability to write coroutines. If you understand reactive APIs, the coroutines build on all this. They're literally the same. So there's an opportunity there as well. I want to thank you all for your time, friends. Thank you so much. I hope you're healthy and happy and safe and have a wonderful show. And thank you for having me.
Okay, thanks, Josh. Nice. Very nice. I'm not going to claim, like I said, with my background that I understood a word of what you're saying, but I really love the fact how you bring it. Because even I, who doesn't understand it, was like, yes, let's glue it together. Let's compose stuff. And that's how enthusiastic you are.
If I can do it, you could do it, buddy.
There you go. Actually, I should dive in. I got some tweets from people saying, like, you should also get into this for next year. So maybe I should do some springtime here. I'm looking at the chat right now. A lot of applause coming in. I don't know if you're in Hopin right now, if you're looking at the same screen.
I should be, I guess. Yeah, I mean, log in. Are there questions? Is there anything I can do to?
They're getting thanks, chapeau, a lot of things. People were laughing when you said, get your kids on there, get your family on there. Someone said that they have a 9-year-old kid that is already deployed.
Wow, that's so great. Really? I love that.
So inspiring. Someone probably while you were doing this at the end said just flat map it.
Yeah, the more common version of that uses a 4-letter word that I won't reproduce here, but yeah, just flat map that. It's a very common thing to say.
More things coming in. We have a 13-second delay on the chat, so I'm just waiting a bit. If you have questions right now, check it. If not, or you have to go because it's already 8 people, you can rate this speech in the polls, and you can connect with Josh, of course, Starbucks man. Read his book, listen to the Beautiful podcast, and he will guide you through it. But in general, I think everybody's psyched because if you look at the chat, it's going crazy.
I appreciate that. I appreciate all of you. I wish I could be there in person, but hopefully next year, right?
Let's all look forward to that if we can do. There you go. It was. Let's end with what Martin is saying in the chat. This was absolutely breathtaking. Thank you, Josh.
Oh, thank you. I appreciate it. Can you send me the chat, or I'm not sure if I'm seeing it. Maybe I'm not. But either way, I appreciate it.
There you go. And one person had a question in the beginning that already disappeared because of all the things coming in. Is they were wondering where they could get the spring T-shirt. They needed some merch.
Oh, this one. I don't know. This one I just printed custom because it's my book cover. But the one that I usually wear, the one that's in my slide, it used to be you could go to store.spring.io. I'm not sure if we still have that. No, it's gone. Reach out to me and I'll see if I can get my European people to send us.
There you go. So connect with him. The T-shirts could be there. Maybe it could be a whole new business.
I don't know. We can't just give them out to everybody, unfortunately. But one or two.
That's true. All right, Josh. I want to thank you very much. You said good morning, so I think you're going to start your whole day. We are wrapping up our day.
Yep.
So
what a wonderful opportunity. Thank you so much.
Thank you. And in the meantime, people are still coming in with the chat. Super happy. Josh was great, and we are at the end of the second day already. It's 8. If you're in the European time, it's just past 8 p.m. So you're in that beer. Maybe you just moved to gin and tonic, whatever. But I'm so happy that people are still here and watching and commenting in the section. So I'm not going to take too much time of the people that are still watching. I'm going to close it up for if you're you at day 1, you're now in day 2, and you're still like, I'm going to do the whole 3 days of OpenSlava, which I recommend. We will start, and like I said, it's not 3:30 anymore. It's 9 a.m. in the morning, Central Eastern Time, in the European time. 9 a.m. in the morning. We will start off. We're going to talk with people that have worked on Game of Thrones. Looking forward to that. Very excited to hear what their experiences are. So 9 a.m. Checking if I forget anything. We're also going to talk about the fjord trends. I had the opportunity, if you don't know what the fjord trends are, to hear them in Prague. And they gave me a book with all the trends coming up. And I thought that was really interesting to see how they wrapped it up in human language and showed what it was possible. So rate the speakers in the polls. Hope to see you tomorrow, or in the chat. Of course, I don't see you, but hope to see you tomorrow, 9 a.m. Early morning, or at least for me. I'm not such a morning person, but I will try to be pumped. I'm checking with my backstage teams because they keep sending me stuff like mention this, mention that. There you go. They say it's all okay. So, Josh, thank you again.
Thank you
for listening, and see you all hopefully tomorrow for the last day of the virtual OpenSlava. Cheers.
Enjoy.
Bye-bye.
Bye.